The James Webb Space Telescope has recently discovered two candidate exoplanets, orbiting their host white dwarf stars. Those are collapsed husks of once great stars. Why is this discovery so exciting? First of all, because these alien planets strongly resemble the largest gas giants in the solar system, Jupiter and Saturn. And secondly, because this discovery might shed light on what our home solar system will look like after the sun's inevitable demise. Our sun is bound to turn into a white dwarf, and this change will most likely destroy the inner solar system all the way out to Jupiter. So far, astronomers have spotted very few planets orbiting white dwarfs. What makes this latest find even more unique is that the planets are more similar to the planets in the outer solar system, in temperature, mass, age, and orbital separation than any other previously found space bodies. It allows us to see for the first time ever what a planetary system looks like after the demise of its star. The candidate planets in question were directly observed by James Webb's mid-infrared instrument while orbiting their parent white dwarf stars. One of these exoplanets is located quite far from its star, at a distance equal to around 11.5 times the distance between Earth and the Sun. The other planet is even further away from its extinguished stellar parent, at a distance of 34.5 times the distance between our planet and the Sun. So far, scientists haven't figured out the masses of the potential planets yet, but they're estimated to be between 1 and 7 times the mass of Jupiter, which is the most massive planet in the solar system. Now, let's sneak a peek into the future. When the Sun runs out of its stellar fuel, and there is nothing left to support nuclear fusion processes in its core, it will swell up into a red giant. It will happen in around 5 billion years, but nuclear fusion will continue in its outer layers, which will reach out as far as Mars, swallowing Mercury, Venus, Earth, and probably even the red planet itself. In the end, the outer layers of our star will cool, leaving behind a smoldering core. Our warm yellow dwarf star will turn into a white dwarf, surrounded by a planetary nebula made up of exhausted stellar matter. The outer planets are likely to drift outward into wider orbits after the Sun goes out. It means that the newly discovered candidate planets might have orbital separations, similar to the ones Jupiter and Saturn will have in the distant future, and if astronomers confirm these space bodies, they will provide us with direct evidence that such planets as Jupiter and Saturn can actually survive the demise of their host star. Researchers have also discovered an interesting fact about the white dwarfs themselves. Apparently, they're polluted with elements heavier than helium and hydrogen. Astronomers call such substances metals. This finding could hint at what might happen to the celestial bodies in the asteroid belt, stretching between Mars and Jupiter after the Sun goes out. Scientists have a suspicion that giant planets, like our Jupiter and Saturn, might cause metal pollution by hurtling asteroids and comets into the surfaces of their stars. The existence of such planets makes the connection between this kind of pollution and planets stronger. And since 25 to 50% of white dwarf stars experience this kind of pollution, giant planets must be common around white dwarfs. It means that 5 billion years from now, Jupiter and Saturn might be hanging out there in the darkness of space, tossing asteroids at the Sun's lifeless body. By the way, about 97% of all the stars in our home Milky Way galaxy will become white dwarfs with time. That's because most stars are not massive enough to turn into anything other than white dwarfs when their lives come to an end. It means that once all the stars in the Milky Way pass the white dwarf stage and cool down into theoretical black dwarfs, the Milky Way will become pretty much invisible.
The James Webb Space Telescope, an astounding piece of equipment built to outperform the Hubble Space Telescope, has made a terrifying and amazing discovery that might completely change our perception of the universe. It has successfully detected a faint glow coming from a staggering 7 trillion miles away. Can this glow be shining city lights coming from some mysterious extraterrestrial world galaxies away from us? Well, let's start from the beginning. A few years ago, NASA's Infrared Spitzer Space Telescope helped us spot a family of 7 rocky exoplanets orbiting the same star. This star is known as TRAPPIST-1, and recently, our new infrared powerhouse, the James Webb Telescope, has measured the temperature of one of those distant worlds. It was a planet called TRAPPIST-1b. Unfortunately, it turned out that this Earth-like planet was totally uninhabitable. Astronomers took James Webb's mid-infrared camera, called MIRI, and looked at the planet's thermal emissions. We can picture the whole process as scientists using heat-sensing Terminator vision. The results were quite disappointing. TRAPPIST-1b turned out to be scorching. Its average temperature was around 450 degrees F. That's as hot as in an oven. Plus, the planet most likely doesn't have any atmosphere. At the same time, this discovery was another record-breaking first for the telescope, which had already produced some newsworthy results by that time. It was the first time researchers detected any form of light emitted by a small and relatively cool exoplanet similar to the rocky planets in our own solar system. No previous telescope had enough sensitivity to measure such dim, mid-infrared light. When 7 TRAPPIST-1 exoplanets were first discovered, the astronomical community was ecstatic. That's because all those faraway worlds were about the size of our home planet and located in their star's habitable zone. It's the region that is just the right distance away from a star for liquid water to exist on a planet's surface. Thus, the planetary system became the best place to look for rocky planets with an atmosphere. But don't get too excited yet. These planets aren't likely to become new worlds for humans to explore, mostly because the TRAPPIST-1 planets are totally out of our reach at the moment. They're just too far away, at a whopping 235 trillion miles away. Their star is also much smaller and redder than our Sun. It's classified as an M-dwarf star. In our home Milky Way galaxy, there are twice as many of such stars as there are stars like the Sun, and they're also twice as likely to have rocky planets orbiting them. It's probably not surprising that astronomers are very interested in such stars. They're the main targets for seeking potentially habitable planets, and it's also way easier and more convenient to observe rocky planets around such smaller stars. But there's a catch. M-dwarfs are more active than our Sun. They frequently flare and spew high-energy rays which are likely to be extremely damaging to planets' atmospheres and any forms of extraterrestrial life. When researchers examined TRAPPIST-1b before, their observations weren't sensitive enough to determine whether this world had an atmosphere, or if it was just a barren rock. But now, we know. The planet is tidally locked to its star, which means that one of its sides always faces the star, while the other is stuck in perpetual darkness. The latest simulations suggest that if this planet had an atmosphere, its temperatures would be much lower since the air would redistribute the heat around both sides of the planet. Unfortunately, the James Webb Telescope recorded much hotter temperatures than needed for such a favorable scenario. It indicates the absence of an atmosphere and knocks the planet off our list of possibly habitable worlds. But the main excitement here isn't actually the features of TRAPPIST-1b. The main takeaway is that James Webb is capable of making such kinds of measurements. It'll help us explore the atmospheres and temperatures of many other distant worlds.
The planet races through space. Its orbit is unstable, like a pool ball gliding across the table looking for a target to collide into. Only this ball is the size of Mars, and it's going 9,000 miles per hour. Boom! It crashes into another planet. This Mars-sized object was called Theia, and what it smashed into was Earth. The impact released 100 million times more energy than the asteroid that wiped out the dinosaurs. The planetary collision threw tons of solid material from both objects out into space. But only one of the bodies survived. Theia was obliterated and then swallowed entirely by early Earth. But that debris didn't go flying endlessly into the cosmic void. No, something crucial happened. All those solid chunks gathered into a cloud. Gravity squished it together, pressing more and more. And in the end, our moon was born. So goes the theory. At the time of the impact, the solar system was just forming, and this rendezvous of epic proportions probably wouldn't have happened if it weren't for a newly formed Jupiter throwing Theia off its orbit and straight into Earth. Our young planet withstood the blow. Time passed, Earth evolved. Its surface will become unrecognizable over the next 4.5 billion years. It's hard for the human mind to understand this vast amount of time, so we'll squeeze it all into one day. If midnight is when Earth first formed from gas and dust that remained after the Sun's creation, the next 4 hours show a lifeless planet. Red hot, covered in lava, constantly bombarded by asteroids and, as you know by now, even a whole other planet. Yet life finds a way. The first cells appear. It's 4 a.m. on the clock. At 2:08 p.m., we see the first single-celled organisms form. It's not until 8:28 p.m. that sea plants appear. 20 minutes later, what's this? Jellyfish. After them, the planet flourishes with different fish, reptiles, insects. The forests grow at 10:30 p.m. Between 10:56 and 11:40, dinosaurs roamed the Earth. The giant lizards ruled our planet for less than 1 hour. A minute before the dinosaurs' extinction at 11:39 p.m., the first mammals begin to run around the planet. At 11:58 and 43 seconds, humans appear. In the cosmic scale of things, we've only ruled this planet for 1 minute and 17 seconds. So here's the main question baffling scientists. Why didn't life on Earth ever stop? It had every chance to cease. Why didn't our planet become like Venus or Mars? They both once had an atmosphere and oceans. Today, they're lifeless deserts. Forget about complex scientific concepts and theories of the universe's structure. Our little rock and all its inhabitants are just incredibly lucky. Professor Toby Tyrrell at the University of Southampton used computer programs and climate simulations to solve the puzzle of why asteroid collisions and ice ages didn't turn our little rock into a lifeless wasteland. The research team took not 10, 100, or 1,000 virtual planets similar to Earth. They used 100,000 for the experiment. And every single one of those 100,000 were simulated 100 times. They exposed these virtual planets to different phenomena. They were bombarded by asteroids, frozen, exposed to epic eruptions of supervolcanoes that blacken the skies and block the surface from the sun's rays. Just 9%, or 8,700 of them, were successful one time in 100 simulations. Of that group, 4,500 planets remain inhabited 10 times. Only on one planet out of 100,000, life didn't stop all 100 times. If life is a lottery, Earth got extremely lucky. In 2009, the unique Kepler telescope was launched into space. Its task? Search one patch of the night sky, or 150,000 stars, for rocky Earth-like planets. Over 9 years in service, it ended up surveying more than 500,000 stars. In all that time, with all those observations over nearly a decade, Kepler discovered 2,600 possible Earth-like planets. The weird thing is, most of them are a type you can't find in our own solar system. They're something between the size of Earth and Neptune. But back to the real Earth. If you go far from the city and look up at the sky, you'll see an ocean of stars. If you're lucky and it's a clear night, with an unaided eye, you could count a maximum of 2,500 points of light. Yet, there are at least 100 billion stars in the Milky Way. Some estimates put the numbers of stars in the Milky Way up to 400 billion. So, where's this giant range coming from? Well, counting stars isn't exactly an easy job. Scientists obviously don't number each one individually, 1, 2, 3, and so on. You know how long it takes to count just 1 billion? Over 100 years. Now, multiply that by 400. Instead, they look at small patches of space and use some complex scientific formulas to make educated guesses of how many stars there are in total. You can do a similar experiment yourself. Imagine a bucket filled with 10 pounds of rock, sand, soil, and other items. Your job? Understand how many rocks are in that mix. We'll count only those rocks that are visible to us from above. Get a rough estimate of their volume and weight, what percentage of the total we can see, and with some calculation, you can get a number. Is it exact? Nah. Why? Because you can't know if the rocks in the bucket are spread evenly throughout, or if they're all about the same size throughout. What if the ones at the bottom, if there are any, are bigger or smaller than your sample view? They could have completely different weights and volumes. That bucket is our Milky Way galaxy, and the rocks you are counting are stars. The point? Scientists can't know for sure how many stars there really are. Maybe 100 billion, or perhaps 4 times that. Of those, 4 billion are like our Sun. With our own galaxy, the most accepted estimate for planets that could potentially support life is 300 million. Though, as the tradition of scientific inexactness goes, that number could be up to 5 billion or more. Either way, lots of real estate to choose from. And that's just the Milky Way. But get this, it's just one of 200 billion galaxies in the observable universe. The most recent research puts that number 10 times higher, something like trillions of galaxies in space. And we've only studied less than 10% of them. As for how many stars there are in the universe, scientists put it at 1 septillion. That's 1 followed by 24 zeros. Again, it's all estimates because we can't know for sure. So far, one thing is clear. Our Earth is the only place in the universe that we know of where there's life. And this planet has done everything it can to change that. Over the past 540 million years, more than 20 major extinction events have occurred. The last one was 66 million years ago. Yep, it was the one that took out the dinosaurs, and 75% of all life on this planet for that matter. An object 7 miles across in diameter smashed into our planet. It was going 120 times faster than the fastest car today. Over 900,000 miles all around the impact site, everything caught fire. A huge tsunami swept across the world's oceans. Billions of tons of dust and sulfur rose into the sky and blocked the sun's warm rays. A global cooling came to Earth. A little over 200 million years ago, there was a lesser-known extinction event that wiped out half of all life on the planet. Most likely volcanoes or an asteroid strike are to blame. Other theories say the movement of tectonic plates triggered another ice age. At that time, huge crocodiles ruled the Earth. They disappeared, and new animals entered the arena of history – dinosaurs. But the worst this planet has ever seen was the Permian-Triassic event about 250 million years ago. 80% of marine life, 70% of land animals and plants, all gone. Volcanoes spewed out a colossal amount of lava where modern-day Siberia is, but it affected the entire planet. Around 445 million years ago, the dominant life form on our planet was marine invertebrates. There was only one continent, Gondwana, and plants were just starting to flourish on land. But something happened that took out 75 to 85% of all living organisms. It could have been an ice age, rising temperatures, or a more daring theory. Some think it could have been a huge star exploding 6,000 light-years from Earth. It launched a jet-like gamma-ray burst that ripped across space, and poor little Earth happened to be in its path. It burned off the ozone layer instantly. Yeah, we kinda need that thing to protect us. Case in point, no matter how much this planet, or even the universe, tries to wipe out life on Earth, which is here in the first place from unbelievable odds, life always finds a way.
The James Webb Telescope, or JWST, is like the ultimate intergalactic paparazzi. It takes pictures of some of the most famous celebrities in the universe. Stars, galaxies, exoplanets, you name it. The James Webb Space Telescope will snap a photo. So if you're a fan of cosmic celebrities, let's take a look at some of these best star-studded photos. The Carina Nebula. The image of the nebula with the beautiful name Carina was published on July 12th. JWST captured a beautiful view of the nebula, located about 7,500 light-years from Earth. Nicknamed the Cosmic Cliffs, it is, in fact, a hotbed of young stars, some of which are several times larger than our Sun. The Carina Nebula is a celestial spectacle located in the southern constellation Carina. It's really huge, approximately 260 light-years across. Massive stars within this nebula are so bright and hot that they create a glowing cloud of gas and dust around them. The Carina Nebula also contains swirling clouds of gas and dust where new stars are being born. The gas collapses under its own weight, becomes hotter and denser, and all this eventually leads to the creation of new stars. However, the Carina Nebula isn't just some peaceful place of star formation. It's the site of some of the most destructive events in the universe, which create massive shockwaves that obliterate everything in their path. Very chaotic and cool. The Stephan's Quintet. This photo was also posted on July 12th. Stephan's Quintet is a visual group of 5 galaxies located at a huge distance from us. About 290 million light-years in the constellation of Pegasus. It's like a cosmic family reunion. All these galaxies are related to each other and interact with each other in some interesting ways. They're pulling and tugging on each other with their gravity, constantly exchanging gas and dust. This interaction is causing some of the galaxies to collide and merge, which can create all sorts of cool effects, like bursts of star formation and supernovae. Thanks to JWST, we were able to see shockwaves, tidal tails, and other amazing details about these galaxies. Their interactions create a stunning sight that we can see in this photo. Jupiter. And here's our old giant friend. This image was published by NASA on August 22nd. Jupiter is the largest planet in our solar system, and it's known for its many moons and its beautiful swirling clouds. But it also has a system of rings, just like Saturn, which are made up of tiny particles of dust that orbit the planet. These rings are much smaller and less visible than Saturn's, but they're still pretty neat. Jupiter also has auroras, which are colorful light displays that occur in the planet's atmosphere. They're caused by charged particles from the solar wind interacting with Jupiter's magnetic field. Just like on Earth, they can be seen near the poles of the planet. But these auroras are much brighter and more intense than ours. We can even see this crazy light show from space. And now, we were finally able to capture this dazzling sight. JWST's photo shows the auroras of Jupiter, its rings, and even 2 moons, Amalthea and Adrastea. It's amazing how bright and clear they are on this photo. The Cartwheel Galaxy. NASA released this image on August 2nd. This photo shows us the Cartwheel Galaxy and its companions. The Cartwheel Galaxy gets its name from its shape. It kind of looks like a cartwheel, doesn't it? This is a giant swirling mass of stars, gas, and dust, which is located in the depths of space. It's shaped like a pinwheel with long spiral arms. These arms are held together by the gravity of the central region, which is home to a supermassive black hole. But the Cartwheel Galaxy is a bit different from its spiral relatives. It has formed when a smaller galaxy collided with a larger one, creating a shockwave that rippled through the gas and dust. We'll definitely have to visit this galaxy someday. It's sure to be a wild ride. Spiral Galaxy M74. And here comes another spiral galaxy. NASA released this image on July 22nd. JWST had to peer through thick layers of dust and gas to see this beautiful star cluster. M74 belongs to a special class of spiral galaxies known as the Grand Design Galaxy. This means that its spiral arms are noticeable and clearly outlined. All sorts of amazing things are happening inside of spiral galaxies. Supernovas, stars being born in clouds of gas and dust, and many other cosmic wonders. The glowing gas and dust the bright stars, and the swirling patterns of the spiral arms make them some of the most striking objects in the universe. Well, we can clearly see it on the example of M74. The Tarantula Nebula. This image of the nebula with a creepy name Tarantula was published on September 6th. The photo covers as much as 340 light-years across. This is a huge distance. Thanks to this image, astronomers have discovered new young stars that were previously shrouded in dust. The Tarantula Nebula is located 160,000 light-years away from us, in the Large Magellanic Cloud. It's the largest and brightest star-forming region in the local group, the galaxies nearest our Milky Way. It's named after its shape, which looks like a bit like the legs of a big tarantula. It's a vast region of space, about 1,000 light-years across, and it's home to some of the most massive and luminous stars in the universe. One of the reasons why the Tarantula Nebula is interesting to scientists is its composition. Its composition is close to the region of stars of the cosmic noon, the so-called state of our universe when it was only a few billion years old. At that time, star formation was at its peak. Thanks to the Webb telescope, we can study this galaxy better and find out what our universe was like at its peak. Neptune's rings. This photo was published on September 21st, 2022. In this photo, we can even see 6 small moons next to the planet, with Triton shining brightly in the upper left corner. You didn't think it was the sun, did you? And yep, Neptune has rings too. They're like the ultimate cosmic accessory. They add a touch of glamour and style to the planet. But unlike some earthly bling, these rings are made of small particles of dust, rather than diamonds and gold. There are 5 known rings around Neptune: the Gall, Leverrier, Lassell, Arago, and Adam's rings. Scientists think that these are relatively young, much younger than our solar system, and much younger than, for example, Uranus's rings. They were probably created when one of Neptune's inner moons got too close to the planet and was torn apart by gravity. We haven't seen Neptune's rings so brightly since Voyager 2 flew past it back in 1989. So this is a great opportunity to take a closer look at these rings. The Pillars of Creation. This photo was published on October 19th. The Pillars of Creation became famous thanks to the Hubble telescope, but this photo is very lush and much more detailed. These columns, located in the Eagle Nebula, are about 5 light-years tall, which is really, really long. And they look like some majestic rock formations, only much more transparent. Just like a typical Hollywood movie set, they're full of action and special effects. They're home to some of the most dramatic processes in the universe. The gas and dust are collapsing under their own gravity, forming clumps that will eventually become stars. The place is full of intense radiation, jets of high-energy particles, and supernovae. It's like a cosmic version of Survivor. And if this wasn't creepy enough, here's another photo published by NASA on October 19th. They shared it right before Halloween. Here, the pillars resemble an eerie hand reaching for something. Brrr. Anyway, all these photos give us a truly awe-inspiring sight. They remind us of the incredible complexity of the universe and the amazing things that are happening even in the darkest and most remote corners of the cosmos. Let's hope that the James Webb Telescope will continue to amaze us in the future.
Aliens might already be out there, and the next generation of space telescopes could actually see them. Not in flying saucers or shadowy silhouettes against the stars, but in the faint, twisted glow of polarized light bouncing off an alien ocean, or in the ghostly signature of molecules that twist in only one direction, the same quirky habit that all life on Earth shares. And the key to unlocking this interstellar mystery, a telescope so advanced, so precise, it could detect life not by accident, but by design. It's called the Habitable Worlds Observatory, and it's humanity's most serious attempt yet to answer the oldest question: are we alone? At first glance, the HWO might look like just another ambitious piece of NASA's long pipeline of missions. one more telescope among many. But make no mistake, this one is different. It's not built to study galaxies or unravel black holes. Its sole purpose is to find life. Not just planets that could be habitable, but worlds that are inhabited, teeming, thriving, alien ecosystems hundreds of trillions of kilometers away. Getting there, though, is like trying to solve a cosmic crime scene. You can't just zoom in and take a picture of the alien equivalent of a rainforest. You need evidence, layers of it. And the HWO is being designed to collect that evidence with surgical precision. Its mission unfolds in 4 stages, each one peeling back a layer of the unknown. First, identify potentially habitable exoplanets. That alone is no small feat. You're looking for tiny, dim specks of light next to the blinding blaze of their parent stars. But HWO is equipped with a built-in coronagraph, a kind of cosmic sunshade that blocks the overwhelming glare of the star, letting the light from the orbiting planet shine through. Second, look for the hallmarks of life. The most immediate clue? Color. Specifically, biopigments, substances like chlorophyll that reflect and absorb light in particular ways. These signatures show up in polarized light, which vibrates in specific directions. HWO's polarimeter is designed to detect those subtle twists and turns in light, revealing whether a distant world might be cloaked in alien greenery. But even that isn't proof. So the third step is to map the planet's surface. Not in high definition, but enough to distinguish continents from oceans, clouds from deserts, and, just maybe, forests from barren rock. Variations in brightness, reflected light, and spectral fingerprints help sketch out a rough global map. Such mapping, though crude, could be the first time humanity ever sees an alien landscape. And then comes the final, breathtaking step, searching for chirality. Life on Earth exclusively uses molecules that are handed, either left-handed or right-handed, but never both. This asymmetry, called homochirality, is a universal trait of biological systems. And astonishingly, it leaves a telltale signature in circularly polarized light, a kind of light that spirals as it travels. Circular polarization is rare in nature, and its biological origins make it stand out like a flare in the darkness. If HWO detects it, we'll be able to trace the fingerprints of alien life without ever stepping foot on that distant planet. Unlike atmospheric gases that can be formed by volcanoes or other geological activity, chirality is incredibly hard to fake. But here's the real challenge. The signal would be faint. Only about 0.1% of the total spectrum, hidden among noise, distortions, and the glare of nearby stars. But HWO's instruments are being engineered to catch it, to sift the whisper of life from the cosmic static. And it's not alone in the hunt. Telescopes like JWST and upcoming ground-based observatories are already scanning the skies, identifying exoplanets that sit within the so-called habitable zones of their stars, regions where conditions might allow liquid water to exist. These discoveries provide the target list. HWO brings the forensic tools. The mission scope goes beyond mere detection. It also aims to characterize these distant environments in detail. How much of the planet is covered by water or cloud, what kind of atmosphere it has, whether there's seasonal variation. These insights would shape how we think about habitability itself, perhaps even redefining what we consider Earth-like. This isn't sci-fi fantasy. The concept is backed by real hardware plans and international support. The Astro 2020 Decadal Survey prioritized HWO as a flagship mission, recognizing its transformative potential. It's a long-term investment, a decade-spanning project that may define the course of space exploration for the rest of the century. Of course, $10 billion is a towering sum, but so is the cost of Hubble and James Webb. And no one today questions the value of those instruments, which revolutionized our view of the cosmos. HWO could be the next step in that legacy, not just expanding our knowledge, but changing our place in the universe. The implications are staggering. Discovering a planet with biosignatures would change science, religion, philosophy, everything. It would force us to rethink life itself. Are we a fluke or one instance of a cosmic pattern? And what if we find nothing? That answer too is monumental. If life is rare, if Earth is truly exceptional, it places a responsibility on us to preserve what we have, because it may be all there is. One way or another, HWO promises to break new ground. It's not about flashy visuals or viral headlines. It's about deep, deliberate science, about asking the hardest questions and building the tools to answer them. When that glimmer of twisted light finally reaches us, it won't just illuminate a distant planet. It will illuminate ourselves.
Hold on to your telescope, Space Rat. Scientists have made an astonishing discovery. They've found the ancient heart of the Milky Way galaxy. But what is this ancient heart? And what does it tell us about the history of our galaxy? Let's find out. Is that it? Yes, and thank you, Captain Jack. My pleasure. What can I say? He's a space pirate. Now, the Milky Way isn't just a candy bar, but a majestic spiral galaxy that's home to billions of stars, planets, and other celestial objects. And it's all spread out over a distance of about 100,000 light-years. The Milky Way has a distinct shape, with a central bulge and spiral arms that extend out from it, kind of like what I look like from the side. The spiral arms are like the suburbs, where the stars are more spread out and the neighborhoods are quieter. They're made up of gas, dust, and stars that all move together in a circular pattern around the center. In between the spiral arms, there are vast regions of empty space, known as interstellar space. Here you can find wispy clouds of gas and dust, as well as some of the most spectacular sights in the galaxy, like massive star-forming regions and colorful nebulas. The Milky Way is also surrounded by a huge halo of dark matter, a mysterious substance that we can't see but can feel its gravitational effects on the galaxy. This halo helps to hold the galaxy together, and it extends out much farther than the visible parts of the Milky Way. And finally, here's the center. Here, the most action happens. In the center of the Milky Way, there's a supermassive black hole, which is about 4 million times more massive than our Sun, Sagittarius A star. This black hole is responsible for some of the most energetic events in the galaxy, like the emission of powerful jets of energy. Remember the famous first photo of a black hole that flew across the internet? It was Sagittarius A star. We managed to capture this black hole because it's the closest one to us. All in all, the center of the Milky Way is full of stars that are tightly packed together, forming a dense cluster. And it was here that astronomers recently made a new epic discovery. The heart of our Milky Way galaxy has been found, and boy oh boy, is it an old-timer. Hey, who are you calling an old-timer? Now, a team of brilliant scientists have found a cluster of 18,000 stars, born right after the Big Bang. Together, they form the ancient nucleus of our Milky Way. These stars date back to a time when our galaxy was just a wee little baby, a mere collection of proto-galaxies, huddling together to form a bigger and better thing. The scientists called it the poor old heart of our Milky Way. Can you believe it? These ancient stars are over 12.5 billion years old. And yeah, maybe they account for a mere 0.2% of our galaxy's total mass. But that doesn't matter. These stars are the building blocks that form the core around which all the other stars and planets took shape. But how exactly did they become this heart of the galaxy? How did they form? And how did we discover all that? To answer these questions, we'll have to plunge into the past, a very, very distant past. Once upon a time, about 14 billion years ago, there was the Big Bang. Our universe was born. At first, it was incredibly hot, but as time passed, things started to cool down and tiny pockets of gas began to clump together due to the force of gravity. These were the first galaxies. The Milky Way is one of these galaxies. It also started as a small clump of gas and dust, but over time, it began to take shape. The very first stars, protostars, began to form within the clouds, and their gravitational pull caused more stuff to come together. This process continued for millions of years until the Milky Way was formed. But to learn the history of our galaxy in more detail, we need to find these protostars, and this is far from an easy task. Researchers have discovered the ancient heart using a neural network to analyze data from the European Space Agency's Gaia mission. The Gaia telescope is a space observatory launched by the European Space Agency in 2013. Its job is to map the position and movement of more than 1 billion stars in the Milky Way galaxy. 1 billion stars! That's like counting every grain of sand on a beach. It's a huge job, but Gaia is up to the task. So, how do they do it? The telescope has 2 cameras that take pictures of the sky at the same time. These cameras are so powerful that they can detect stars that are 1 million times fainter than those visible to the naked eye. Gaia takes many pictures of each star, and this allows us to track their movements with incredible precision. Thanks to the data collected by Gaia, astronomers are learning more about the structure and history of the Milky Way. They've discovered new details about the stars, including their ages, temperatures, and chemical compositions. Gaia is also helping astronomers search for exoplanets, or planets that orbit stars outside of our solar system. So, for this research, astronomers used Gaia and the most accurate 3D map of the Milky Way ever compiled. They had to analyze around 2 million stars to find the primordial group. One way that astronomers can determine the age of stars is by looking at its brightness and temperature. This way, they study a brief phase of stellar evolution known as subgiants. But imagine searching through the huge center of the Milky Way for the tiniest group of stars that are older than 12.5 billion years. This is like searching for a needle in a haystack. Luckily, they had a trump card up their sleeve: metals. You see, in the early universe, the cores of these stars were so hot and dense that they were able to smash atoms together to form heavier elements. These heavier elements are called metals in astronomy, even though they're not really metals like the ones we're used to. The more massive the star, the more metals it can create during its lifetime. When the life of the first stars came to an end, they made a big boom and scattered these metals all around. Metals mixed with other gases and joined the newborn stars, and so on. As time passed and the universe got older, more and more generations of stars formed, each one richer in metals than the last. Can you guess what that means? The older the stars, the less metals they should have. So now it was time for some galactic archaeology. The team taught the AI to find the metal-poorest, most ancient stars, and it succeeded. It found a huge cluster, and all of them were within 30,000 light-years from the center of the Milky Way. Then they separated out the stars that formed the ancient heart from the stars that originated in a dwarf galaxy. And finally, we were left with the original stars around which the Milky Way grew. This discovery is incredible. It reveals the remnants of the Milky Way's earliest history. It turns out that simulations of the Milky Way's formation were spot on. The old stars existed just where they were predicted to be. Just imagine, the stars that remember our universe as a baby are still hanging out in the center of our galaxy. Isn't that mind-boggling? So, why is this such a big deal? Well, by studying these ancient stars, scientists have discovered some incredible things. For example, they've confirmed that the Milky Way's core began its life stationary and only picked up rotational speed as it grew. In other words, the Milky Way formed from the merging of 3 or 4 protogalaxies, and these stars were its initial core. But even after billions of years and multiple mergers, the heart of the Milky Way has remained intact, like a sheltered oasis in the midst of cosmic chaos. All in all, the Milky Way is a vast and complex place, full of mysteries and wonders waiting to be discovered. It's a true marvel of the universe, and we're lucky to call it our home. But the research isn't over yet. Scientists are eager to learn even more about the formation of the Milky Way, and hope to study these ancient stars in even greater detail. Who knows what secrets they might uncover? Maybe they'll even discover what types of supernovas exploded to create the elements we see today. So, get ready, Space Rat! The adventure is just beginning! Arr!
It's been more than a year since the James Webb Telescope, which had taken over 20 years to complete, was launched. And for such a relatively short time, the ultra-modern and most powerful in history piece of equipment has already made plenty of discoveries. By observing the universe at infrared wavelength, James Webb lets us see things no other telescope has ever shown before. The primary goal of this incredible piece of equipment is to study the formation of galaxies and stars that appeared in the early universe. For example, look at the closest to us stellar nursery, a region of space where new stars get born. NASA has shared an image from James Webb that shows a small star-forming region. If you look at the picture attentively, you'll see jets bursting from infant stars. Around them, different colored clouds of cosmic dust are colliding with one another. The view is mesmerizing. The red dust consists of molecular hydrogen. You can also notice that some stars have something like shadows. Those hint at the creation of what will later become planets. At first sight, the image may seem chaotic, but astronomers claim that it's a relatively small and quiet stellar nursery in comparison to some others. Many young stars there are similar in size to our Sun, or a bit smaller. The photo itself was taken with the help of Webb's near-infrared camera, NIRCam. It's the observatory's primary camera that snaps images of the cosmos in 2 different infrared ranges. Another amazing discovery the Webb telescope has made is smoke molecules in a distant galaxy. It's the first time such molecules have been discovered so far away from our planet. The galaxy in question lies 12.3 billion light-years away from Earth. It most likely formed about 1.5 billion years after the Big Bang. Despite such a huge distance between the galaxy and our planet, scientists have managed to detect chemical compounds found in soot or smoke, and it's quite a big deal since it has pushed the record for detecting similar complex molecules back by around 1 billion years. This study has also confirmed the sheer power of the coolest piece of space equipment of all time. It managed to make this discovery despite the fact that the spectrometer needed for the measurements didn't perform to the fullest after having experienced a sudden and surprising degradation. The James Webb Telescope has also helped to boost our understanding of exoplanets. Those are planets orbiting stars other than our own Sun. At the beginning of 2023, the observatory spotted its first exoplanet, LHS 475b. It's located 41 light-years away from Earth and is approximately the same size as our planet. According to NASA, nowadays, James Webb is the only operating telescope capable of categorizing the atmosphere of Earth-sized exoplanets. The research team behind the discovery believes such results underline the precision of the telescope. They hope that it will help us locate many more rocky exoplanets that we might be able to colonize in the future. Even though, at first sight, it may seem that the universe is pretty empty, it's actually a very busy place, and Webb has all the necessary instruments to see all kinds of cosmic events happening out there. Just look at this image of WR-124. It's a star on the cusp of its explosive demise. In the image, the star is about to go supernova. It happens when a star runs out of its fuel and explodes at the end of its life cycle, releasing a giant cloud of space dust and hot gas into space. The star captured by the Webb telescope was at the Wolf-Rayet stage of its life. That's a period when a star is shedding its outer layers before going supernova. The next amazing thing discovered by James Webb is a star-planet hybrid with very strange clouds. This bizarre world, VHS 1256b, is actually a brown dwarf. Those are bigger than planets but too small to classify as stars. They emit some light of their own and are quite hot, but their mass is simply not enough to fuse hydrogen into helium like full-fledged stars do. Space bodies of this kind aren't actually brown. They occur in a wide variety of colors, but those are mostly invisible to the human eye. What we can see is the light they emit, and to us, it appears to be dark orange or magenta. The brown dwarf discovered by the Webb telescope is almost 20 times the size of Jupiter. It orbits 2 red dwarf stars, and to complete one orbit, it needs over 10,000 years. Astronomers first found out about this unusual exoplanet in 2016, but at that time, they didn't classify it as a brown dwarf, and, thus, couldn't explain its puzzling reddish glow. Now, thanks to the James Webb Telescope, they know the space object's origin. Anyway, back to those clouds. As you know, clouds on Earth are made of water vapor. But those on the brown dwarf are different. They seem to be made of sand. It looks like good old sand from Earth, but it's actually not. The clouds are made of tiny particles of silicate. Another recent discovery involves several large galaxies that scientists believe were born not long after the Big Bang. They aren't supposed to be there, and no one expected to find them. But the James Webb Space Telescope has spotted them. These galaxies, as massive as our home Milky Way, are full of mature red stars. Astronomers have analyzed the light coming from them and estimated their age 500 to 700 million years after the Big Bang. It means that they came into being when our universe was very young, almost a baby. But the most bizarre thing about these galaxies is their tremendous size and the age of the stars dwelling there. The data received by the telescope don't coincide with the existing ideas about what the universe looked like and how it evolved in its early years. It also doesn't match the earlier observations made by Hubble. And here, James Webb has captured a distant region of space in unprecedented detail. This section of space is known as Pandora's cluster. In the image, you can see 3 massive clusters of galaxies coming together and forming a megacluster. The combined mass of these clusters acts as a powerful gravitational lens. And thanks to this natural magnification effect, scientists can see other galaxies in the region. Astronomers claim that the most recent image of Pandora's cluster is stronger and deeper than they have ever seen. James Webb has also managed to spot thousands of young stars never seen before in the Tarantula Nebula. This space formation got its nickname because of the appearance of dusty filaments spotted in previous images. It's the biggest star-forming region in the local group, which includes the galaxies nearest to the Milky Way. The Webb telescope's images have helped to shed light on the composition of the Tarantula Nebula. The telescope has also detected protostars, infant stars in the process of gaining mass. Astronomers expect that these protostars will eventually form and shape the nebula further. Among other discoveries made by the James Webb Telescope, you can see the birth of 50 distant stars. Some of them power protoplanetary disks, which might later form solar systems light years away from our own. Here's one more image from James Webb. You can see a supermassive black hole that has a mass of 9 billion suns. It's so ginormous and ancient that scientists are struggling to explain its existence. Astronomers have also discovered a distant ring of dust, rock, and gas that contains a chemical called methylcation. It's known as a molecular building block of life, and it makes most of the organic material on our planet. James Webb helped researchers see powerful sandstorms on a planet 235 trillion miles away. Astronomers were happy to discover this treasure chest of countless tiny sand particles. Now look at this. Do you recognize this image? Those are the so-called pillars of creation. But this new view shows us just how star-speckled that dusty region actually is. You can compare the new photo with the one taken by Hubble in 2014. This is astonishing proof of scientific progress.
A recent shocking discovery, shocking I tell you, shows that one galaxy can devour another smaller one, leaving behind just faint remains. Can anything like this happen to our home Milky Way galaxy? And if it does, what will happen to the inhabitants of the planet Earth? You know, us. Well, let's figure it out. This whole discovery is actually a curious story. Even before the Rubin Observatory, an astronomical observatory in Chile, even started its full science work, it accidentally helped astronomers spot something totally unexpected. In June, the team released its very first test images, and one of them showed a deep look at the Virgo cluster. That's a huge group of nearby galaxies scientists have been studying for years. But in the bottom right corner of that image, there was something thin and strange, and it wasn't me. It was a tiny razor-sharp streak of stars stretching away from a well-known galaxy called M61. No one had ever seen it before. Now, M61 looks a lot like our own Milky Way galaxy. It's a barred spiral galaxy with long, sweeping arms. But despite the similar shape, the center of M61 is far more dramatic. While Milky Way's supermassive black hole sits quietly, almost as if it's asleep, M61's black hole is wide awake and hungry. It feeds on surrounding matter and blasts out powerful flows of energy, which creates a kind of galactic storm that spreads through the galaxy. M61 has been studied for decades, but Rubin's camera is built to pick up things that are extremely faint. That's why this new star system suddenly appeared. It was as if someone turned on a flashlight in a dark room. Now, the stream is enormous. It's about 50 kiloparsecs long, which is roughly 163,000 light-years. That's more than the size of the entire Milky Way. Most stellar streams around our own galaxy are only a few tens of thousands of light-years long, so this one is huge by comparison. Scientists think that the long trail is made of a dwarf galaxy that got too close to M61. Once it crossed into the larger galaxy's territory, the dwarf galaxy became trapped in its gravitational grip. Little by little, powerful tidal forces began pulling it apart, stretching it into a long, faint trail of stars. Eventually, it was completely ripped apart by M61's gravity. When that happened, the larger galaxy seemed to have responded with a burst of new star-making about 10 million years ago. It almost felt like the collision kicked it awake. This process, large galaxies tearing smaller ones apart, is thought to be one of the main ways galaxies, like the Milky Way and M61, grow over billions of years. Each smaller galaxy that falls in becomes fuel for the larger one, adding stars and gas, and sometimes this process can even stir up activity around the central black hole. Will our Milky Way become that smaller galaxy one day? Well, we do have a much bigger neighbor, the Andromeda Galaxy. But at the moment, we can't predict whether it'll get hungry enough to attack the Milky Way. Whew, what a relief. Anyway, it might seem weird that the M61 stream had gone unnoticed for so long. It wasn't exactly faint or subtle, glowing with the light of about 100 million suns. Hard to miss. But it managed this trick by staying hidden behind a nearby galaxy. This makes it really difficult to detect even bright stellar streams. To find them, we need extremely sensitive instruments and careful techniques. At least now we know that giant galaxies may grow by eating smaller ones, leaving long trails of stars behind as evidence. The researchers admit that it's surprising that such a huge structure stayed hidden around a famous galaxy for so long. And it seems that the discovery of the M61 stream is just the beginning. The night sky might start filling with new, uncovered structures, ghostly trails, forgotten galaxies, and the remains of ancient cosmic encounters. The Rubin Observatory is a brand new astronomy center built on a mountain in Chile. Its full name is the Vera C. Rubin Observatory. It was named after the astronomer who first found strong evidence that dark matter is real. Now, what makes Rubin special is that it's the first telescope of its kind. Its giant mirrors, super-sensitive camera, fast movement, and powerful computers all use cutting-edge technology. The main telescope, called the Simony Survey Telescope, has a 27-foot mirror, and it uses the LSST camera, which is the biggest digital camera ever made. But we'll talk about it a bit later. For 10 years, this telescope will take extremely detailed pictures of the southern sky. It will scan the entire sky every few nights, creating a huge, high-quality time-lapse video, the largest movie of the universe ever recorded. This movie will help scientists spot things that change over time, like asteroids, comets, stars that get brighter or dimmer, and exploding stars called supernovae. To create this giant time-lapse, the Rubin Observatory will have to use a lot of new technology. Some of its parts were invented from scratch, and others were improved versions of older designs. It'll help scientists discover all kinds of things. Many we already expect, and many we can't even imagine yet. Even so, Rubin Observatory was built with 4 main science goals in mind: learning more about dark matter and dark energy, creating a complete list of objects in our solar system, mapping the structure of the Milky Way, and studying objects that move or change brightness over time. Everything about the telescope, its huge size, fast scanning speed, An ultra-sensitive camera was designed to make discoveries in these 4 areas as complete as possible. Rubin's telescope isn't the first telescope with a mirror about 27 feet wide, but it is the first to combine its primary mirror and tertiary mirror into one single surface. Putting both mirrors together is a special innovation that makes the entire telescope more compact. Because of this, it can move faster and get ready for its next observation much more quickly. The telescope's LSST camera is the biggest digital camera ever created. It's about the size of an SUV and weighs around 6,000 pounds. It holds a giant 3200 megapixel CCD array. Just one single picture from Rubin is so large that you'd need about 400 Ultra HD TV screens to display it. It's also the fastest-moving large telescope on Earth. Rubin's telescope can swing into a new position in only 5 seconds and immediately start taking its next image. This speed comes from the telescope's compact design, thanks to its 2-in-1 mirror and its powerful drive motors. They can quickly move and stop the 220-ton telescope mount without shaking it. Even small vibrations can ruin an image, so this stability is a huge achievement. By the way, if the telescope were spinning at full speed, you wouldn't be able to outrun it. Also, Rubin Observatory has a rare combination. It can collect a lot of light and capture a very large area of the sky in a single picture. This means it can spot faint objects spread out over a wide region without needing many separate images. When you add the telescope's incredible speed, you get the perfect setup for creating Rubin's ultra-high-definition 10-year time-lapse of the universe. A fun fact, each Rubin image covers about 10 square degrees of sky. That's the same area as 45 full moons, or about the size of a golf ball held at arm's length. Another cool thing is that Rubin data will be immediately available to scientists in the US and Chile, and to members of Rubin's International In-Kind program. They'll be able to access everything through an online portal, which means that no giant downloads are needed. After 2 years, the entire world will be able to view Rubin data. Rubin will also process new images every night in near real time. If something in the sky moves or changes, the system will send out a public alert within 60 seconds. This will allow scientists to respond quickly and point their telescopes at the event. Each night, Rubin Observatory will create 20 terabytes of data and send out up to 10 million alerts about changes in the sky. By the end of the 10-year survey, Rubin will have produced a whopping 60 petabytes of raw images. It'll be the first time so much astronomical information is shared with so many people. You may have heard that NASA will launch a mission to Saturn's largest moon, Titan, in 2028. And, well, a lot can go wrong. The Dragonfly spacecraft will hit a thick atmosphere at insane speed, survive a fiery plunge, hop its parachutes, and then land in a spot way colder than Antarctica. And if you're picturing a giant Star Trek-style spaceship, nah. Dragonfly is basically a high-tech drone, about the size of a Mini Cooper. So, can something that small really survive all that? Well, it better survive, especially since the project is already 2 years behind and keeps getting more expensive. NASA selected the Dragonfly mission in June 2019, and the launch was scheduled for 2026. But now, it's been pushed back to 2028. That delay alone added about $1 billion to the total cost. At this point, the project costs over $3 billion. All that money is going into building a nuclear-powered car-sized craft with 8 rotors, kind of like a drone. It'll be fast, able to travel tens of miles in less than an hour, and it will take about 6 years to get to Titan. So, if the current launch date holds, it should land over there by 2034. But why Titan exactly? Well, that's because Titan is weird, in the best way. It's Saturn's largest moon. It's also bigger than our own moon and the planet Mercury. Titan's atmosphere is thick. The air pressure there is about 60% higher than Earth's, which is kind of like the pressure you feel at the bottom of a deep swimming pool. But the main reason everyone's so interested in Titan is that it has all the ingredients for life. This world is packed with complex carbon-based chemicals. On Earth, carbon is at the center of all living things. It helps form our cells and body structures, and it's involved in the chemical reactions that keep life running. Without carbon, life as we know it wouldn't exist. Then there's water. Okay, Titan is just too freaking cold to have liquid water, but there's ice. It also has clouds, rain, rivers, lakes, and seas of liquid hydrocarbons like methane and ethane. On top of that, scientists think it might have a liquid water ocean hidden under its icy crust, similar to what we believe exists on Jupiter's moon Europa. In many ways, Titan may resemble what Earth was like billions of years ago before life fully developed into what we see today. By studying Titan's chemistry and environment, scientists hope to spot chemical fingerprints that could point to past or even present life. One of Dragonfly's main targets is the Selk impact crater. Scientists think something slammed into this area a few 100 million years ago, and that impact may have piled up the right ingredients for life in one spot. We're talking about a mix of carbon, plus hydrogen, oxygen, and nitrogen. Now, on paper, this mission sounds amazing. Send a flying robot to Titan to understand how life must have begun. But when you get into the details, you realize just how hard it is. Flying a drone in such a remote world is something relatively new and, honestly, a bit daunting. There's very little room for mistakes. So, over the last few years, scientists have been running all kinds of technical tests. And that's super important, because Dragonfly isn't just getting there and flying back. It's going to spend about 2.5 years operating and exploring different spots around Titan. And since the air there is much thicker than Earth's, Dragonfly's rotors won't behave the same way they do here. If you want to know whether it can lift off, stay steady, and steer properly, you can't just guess or use normal drone experience. You have to recreate Titan's air conditions here on Earth to see how the craft will fly over there. That's why they decided to test it in this huge wind tunnel at NASA's Langley Research Center located in Virginia. But they didn't just blow regular air through it. Instead, they pumped in a gas called R134 Freon. This gas helps them to imitate the way Titan's thick atmosphere would push and swirl around the rotors. The idea is to test how Dragonfly will handle the air pressure, check its vibrations, that kind of stuff. It was only after running simulations that the problems started to show up. And it turns out Dragonfly had quite a few. From the start, engineers knew the landing on Saturn's moon would be a huge challenge. On Mars, for example, spacecraft go through a fast, intense landing that NASA often calls the 7 minutes of terror. But on Titan, Dragonfly's descent and landing is expected to take much longer, around 2 hours. The descent will be really tough. As Dragonfly drops into Titan's atmosphere, it'll be sealed inside an aeroshell. It's basically a heat shield designed to handle the intense friction and heat during entry. NASA also designed parachutes that will deploy later and slow the spacecraft down bit by bit. These parachutes have to work for a long time, up to 110 minutes. But tests show that the aeroshell could wobble a lot or even start to tumble during that long stretch. So NASA had to adjust the parachutes to help keep the spacecraft stable. After that tough descent, we can all celebrate, right? Well, not yet. Because as soon as the Dragonfly lands on the surface, it could face a different problem – overheating. And that sounds weird, considering Titan is insanely cold, with temperatures that can drop to about minus 290 degrees Fahrenheit. So, at first, scientists thought their main job would be keeping Dragonfly warm while it stays over there. That's why the original plan was to give Dragonfly a special power source called a multi-mission radioisotope thermoelectric generator. Well, that's a mouthful. It's the same kind of nuclear-powered generator used on the Curiosity and Perseverance rovers on Mars, and it provides both electricity and heat. But when researchers ran simulations, they found the design could cause the opposite problem. If there's no wind on Titan, like on a totally calm day, Dragonfly might not be able to get rid of the heat, and then the lander could overheat. In simple terms, even on a freezing world like Titan, that generator could put out enough heat to make parts of Dragonfly too warm. And then, the mission is basically over. Titan's thick atmosphere causes another tricky problem. On Earth, the atmosphere and weather can change pretty quickly because our days and seasons move along fast. But Titan runs on a much slower clock. One full day on Titan lasts about 16 Earth days, and 1 year there takes almost 30 Earth years. Since everything changes so slowly, the atmosphere doesn't shift as suddenly as it can here. And that slow pace affects temperature too. On planets like Mars, the temperature can swing a lot between day and night. Titan isn't like that. Thanks to its dense atmosphere, the temperature stays pretty steady. Now, the changes may be small, but scientists still have to take them seriously. So they put Dragonfly through a series of tests, and it passed. Thankfully, it looks like the craft's heating and cooling system can handle those subtle shifts. Now, you might be wondering, okay, but how does it actually move around? Well, because by now you know Dragonfly is like a drone. I mean, it doesn't have wheels. It has propellers and landing skids, so it can't just drive across the ground. Instead, it's meant to travel by flying. It will take off straight up, fly to a new spot, and land again, over and over. All this makes Dragonfly an amazing engineering project. But because it's so bold, there are still a lot of concerns. That's exactly why NASA is testing everything and taking every precaution to give it the best shot. And if it works, Dragonfly could help us find clues about how life on Earth first began. Maybe we'll find signs of life out there, or maybe discover something even bigger. But it's hard to know what Titan is really hiding for now, so we'll just have to wait for 2034. No one will hear your cry in space, or something like that. We've all heard this famous chilling phrase, and it's actually true. Space, for the most part, consists of a giant nothingness. There's a lot of, space in space. But this doesn't mean there are no sounds in space. In fact, there are plenty of them, and some of them can even make you shiver. Let's take a look at the scariest space sounds. First of all, how are cosmic sounds even recorded? Sound is just the vibration of molecules. When you scream, you make the molecules push each other furiously until they reach the ear of the person you're yelling at. Then these vibrations get transmitted to the brain, and we recognize them as something that you might need to apologize for. In other words, to hear something, we need molecules. And that's where things get complicated. There aren't any of them in space. The entire universe almost completely consists of a vacuum. No, not a Hoover. Absolute nothingness. However, the wizards from NASA still record space sound somehow. So how do they do it? The thing is, there are some types of waves that don't care about molecules. We regular folk can't perceive them without some special devices. These waves include, for example, radio waves. We'll need a radio or something like that to recognize them. And that's exactly what NASA's satellites do. They catch random radio waves. Thanks to their heroism, we can find out how different cosmic bodies sound. These satellites record a variety of waves, fluctuations of plasmas, magnetic fields, and other, stuff. And then scientists from NASA transform all this into normal soundtracks. And some of them sound quite frightening, to put it mildly. Let's take our magnetic field, for example. It surrounds our planet like an invisible shield, protecting us from all sorts of nasties, like radiation and solar winds. At the same time, we can neither see it, feel it, nor hear. Oops. Well, the last one is outdated. Scientists from the Technical University of Denmark took magnetic waves recorded by the ESA swarm satellite. They converted them into an audio track and got a pretty creepy result. Now, to be honest, it sounds more like an eerie entity stalking you in the middle of the night. And if you remember the maps of Earth's magnetic field, it starts to feel like a spider crawling nearby. Ew. And this isn't the first strange sound that we caught on Earth. Recently, we caught another weird radio emission from space. Scientists found out that the repeating signal came from somewhere very far away, like billions of light years away from us. Such fast radio bursts usually lasted no longer than a few milliseconds, but this one was unique. It lasted about 3 seconds, basically thousands of times longer than usual. And at the same time, the signal was very precise, so much so that scientists even compared it to a heartbeat. Scientists believe that this signal is caused by pulsars, or neutron stars. One time, Nikola Tesla caught something similar, but unfortunately, at that time, We didn't know about such things as pulsars, so Tesla was sure that he had caught a message from some extraterrestrial life. It's a pity that the truth turned out to be much more boring. But let's move on from the Earth to the Moon. In 1969, the astronauts of the Apollo 10 mission, the spacecraft that made the final test flight to the Moon, flew past its surface. And then they caught some strange signals coming from the dark side of the Moon, the side that we never see because the Moon is tidally locked to us. The sound was so weird that the astronauts weren't even sure whether to report it to NASA. They were afraid they wouldn't be taken seriously, and maybe even not allowed to participate in the next space missions. Here's what it sounded like. But according to NASA, it's not some creepy extraterrestrial music at all. These may just be some radio waves that affected each other because of their proximity, although the astronauts who heard it for the first time probably felt a little creeped out. Let's move to the other planets. Now, 40 years ago, scientists actively explored the surface of Venus. They sent as many as 10 probes there, which were supposed to capture audio and video shooting from the surface. Now we know what Venus, which could easily destroy us at any attempt to even get close to it, sounds like. Horrifying. And you wouldn't expect anything else from the most dangerous planet in the solar system. Unfortunately, Venus is even more toxic than the average Twitter user. So these probes didn't last too long. They heroically arrived on a planet and soon broke down. Next one is Jupiter. This space giant, which is 11 times larger than the Earth, never fails to scare us. One of NASA's probes, Juno, flies around Jupiter every few weeks. The probe is moving at a tremendous speed, 130,000 miles per hour. One day, Juno caught one of the strongest invisible signals it had ever encountered. This was the point at which the mad solar wind came into conflict with the magnetic field of Jupiter. It kind of sounded like a cosmic boom. The original sound lasted 2 hours, but it was compressed to a few seconds. It actually sounds more like a collision of a sea wave and a rock. But here, in terms of horror, Jupiter surprisingly loses to one of its small moons, Ganymede. In 2021, the Galileo space probe flew past Ganymede, and during its flight, it received a rather strange recording. These sounds are satellite radiation, and it's unclear whether it sounds like a cozy sunny day in the jungle or like thousands of bats waiting for you in the night. Next one is Saturn. This signal was caught by the Cassini-Huygens Automatic Interplanetary Station, which was launched into space in 1997. When flying past Saturn, Cassini recorded a pretty scary sound. This terrifying cry of thousands of souls is actually just some radio waves. They aren't too different from what the auroras emit on Earth. A little later, Cassini received another recording, the sounds made by lightning and thunderstorms on Saturn. They sound pretty interesting, too. More like popping corn or a Geiger counter, right? But that's just because these lightning strikes have a crazy frequency. Moving on from the solar system to outer space. The famous Voyager 1 was launched back in 1977 and continues to send us data even 40 years after its launch. In 2012, it left the solar system and entered interstellar space. And then, while abandoning its home, Voyager 1 detected the sound of plasma waves. The original recording lasted 7 months, but fortunately, scientists felt sorry for us and reduced it to 12 seconds. It isn't really eerie, but is still kind of unsettling. And although it feels like nothing can beat Saturn's horrors, let's end this tournament with one of the scariest objects in the universe, a black hole. This sound was recorded by the Chandra Space Telescope. While studying a cluster of galaxies in the constellation Perseus, they discovered something strange. Some undulating movements appear from the center of the cluster. They spread out in all directions, like circles on the water. Scientists have suggested that this was caused by a supermassive black hole. The thing is, black holes don't always devour space objects entirely. Sometimes they kind of spit them out. This causes vibrations of gases, which we can convert into sound tracks. What's interesting is that the oscillation of each such wave actually lasts about 10 million years. You're just listening to a very accelerated recording. Scientists have reduced the delay between oscillations by about 144 quadrillion times. So let's check it out. This is probably the eeriest sound from the whole list. Nothing too loud or wild, but there's something dark and disturbing about it. Now, those were the scariest space sounds captured by NASA. To be fair, most of them sounded creepy simply because they're radio waves, but it's still fun to get spooked sometimes. One of the biggest stars we've ever found is wobbling on the edge of disaster. And it won't go quietly. It might collapse in on itself and instantly become a black hole, or explode in a blinding supernova. It might even crash into its companion star, and we could probably see it. The star in question, WOH G64, wow, that's a mouthful, I'll nickname it Jerry. So Jerry is a red supergiant. These are huge stars at the end of their lives. Like cosmic seniors, they've already burned through most of their fuel, puffed up to an enormous size, and are getting ready to explode as a supernova. They're cooler on the outside than many other big stars, that's why they glow red instead of blue or white. Still, the biggest and brightest of these stars are kind of a mystery. Astronomers aren't totally sure what happens to the most extreme ones right before they explode. When they look at the sky, they don't see as many ultra-bright red supergiants blowing up as they would like to. Instead, they see hints that some of them might change color and heat up again before the end. One famous example is our star called WOH G64 in the Large Magellanic Cloud. That region is basically a stellar nursery. It means it's packed with thick clouds of gas and dust where stars are born. It's the perfect place to grow something extreme. Now, for decades, we considered Jerry one of the most outstanding red supergiants ever found. It's enormous, it's incredibly bright, like me, and losing mass like crazy. It's also surrounded by so much dust that it looks heavily wrapped up, like it's hiding inside a thick cosmic blanket. But recently, something weird happened. The star's light signature started to look completely different, as if this red supergiant had changed identity. Now scientists think Jerry isn't just a single star. It's probably a rare pair of stars locked together in a relationship called a symbiotic binary system. In this system, the red supergiant seems to have transformed into something hotter and more unstable, called a yellow hypergiant. Now, yellow hypergiants are like the middle phase before total destruction. They're enormous. Some are so big you could fit billions of suns inside them. But they don't last long. This stage is brief and chaotic, like a star pacing nervously before its final act. Yellow hypergiants are extremely rare because they represent a short transition between the red supergiant phase and the final explosion. We know of only a few dozen confirmed examples. Now, why would that transition happen? One possibility is stellar drama. Ooh, what could happen? Well, as we know, Jerry isn't alone. It likely has a companion star. The two may have interacted so intensely that the red supergiant blew off a huge chunk of its outer layers. Imagine two stars spinning around each other so tightly that one basically starts stealing material from the other. That lost material could have formed a massive cloud, a shared envelope that briefly swallowed both stars. But there's another possibility. Even without interference from a companion, a star this massive can become unstable on its own. It might have gone through a huge eruption that lasted more than 30 years and is now settling down into a hotter yellow phase. Whatever it is, this is incredibly rare, like watching a star evolve in real time instead of over millions of years. In any case, after watching this monster star suddenly change before their eyes, astronomers now think it may be getting close to the end. A new study claims the star could be on the verge of exploding in a massive supernova. Or, since it's so unbelievably heavy, it might skip this step completely and collapse straight into a black hole. Now, Jerry was discovered about 50 years ago and labeled a red supergiant. It has about 30 times the mass of our Sun. But the really mind-blowing part is its size. If you drop this star into the middle of our solar system, it would stretch all the way past Jupiter. Stars like this live fast but not long. Jerry is only about 5 million years old. That might sound ancient until you remember our Sun is 4.6 billion years old and still going. The problem is, massive stars burn through their fuel super fast. That's why they shine so bright, grow to ridiculous sizes, and then go out in a blaze of glory. Now, we don't know how it'll happen, but because of its enormous mass, Jerry's demise won't be quiet. In cosmic terms, it could happen soon, meaning within a few hundred to a few thousand years. It might explode in a supernova, blasting its outer layers into space. Or it could collapse inward so violently that it forms a black hole on the spot. There's even a chance it could eventually slam into its companion star. So let's say our red supergiant tears itself apart in a supernova. Then we need to learn more about these space fire shows. Supernovas are gigantic explosions that happen when massive stars finally collapse. They're incredibly important to how we understand the universe. Astronomers use certain types of supernovas, like measuring sticks, to figure out how far away galaxies are. In fact, it was supernovas that tipped scientists off in 1998 that the universe wasn't just expanding, it was actually speeding up. But there's one problem. Even though supernovas are powerful and bright, they happen incredibly fast. Catching the exact moment a star explodes is like trying to photograph a lightning bolt at the exact second it strikes. But an international team of astronomers says they managed to do exactly that. They got the earliest and most detailed look ever at a supernova right as it was blowing apart. Using the European Southern Observatory's Very Large Telescope, they basically watched the shockwave from the collapsing star blast through its surface. For the first time ever, they could actually see what shape the explosion had. And that shape does matter. When a massive star runs out of fuel, things go bad fast. For millions of years, the star balances two forces: the nuclear fusion in its core pushing outward and gravity pulling inward. But once the fuel is gone, gravity wins instantly. The outer layers crash inward, slam into the collapsed core, and rebound outward in an intense shockwave. That shockwave tears through the star and blows it to pieces. The result is a supernova. That's the basic idea. The details of how that shockwave forms have been hard to pin down, because supernovas are nearly impossible to catch in the act. Out of the trillions of stars out there, astronomers would need to be already looking at the exact right star at the exact right moment. And it would have to be close enough to study before expanding gas clouds block the view. This time, they got lucky. The explosion happened about 22 million light-years away, which also means it happened 22 million years ago. Think about that. Astronomers spotted it quickly and managed to start observing it within just 26 hours after it was first detected. In supernova terms, that's incredibly fast. They used a technique called spectropolarimetry, basically a way of studying how light is scattered and how its vibrations are aligned to figure out the shape of the blast. What they found was surprising. The explosion wasn't perfectly round. Instead of expanding like a smooth sphere, the shockwave stretched out slightly, more like an olive than a ball. When the blast slammed into the gas surrounding the star, it flattened, but it still expanded evenly along that stretched shape. It means the very first light and material didn't shoot out evenly in all directions. The explosion had structure right from the start, and that structure gives clues about what was happening deep inside the star when it collapsed. Now, here's another interesting fact. The star that went supernova was a red supergiant, about 12 to 15 times the mass of our Sun. And based on how many red supergiants are out there, astronomers expected to see lots of them exploding. But for years, they didn't see many. It was almost like these giant stars were disappearing quietly. More recent observations from the James Webb Space Telescope suggest they probably are exploding. We just couldn't see them clearly before. Maybe because dust and gas were hiding the blasts. And now, this new observation suggests their explosion might actually follow a common pattern, with a clear stretched shape rather than a perfect sphere. In other words, these cosmic explosions may be more organized than we thought. Ever wondered what it would be like to hear the sound of a black hole? NASA's got you covered. Here is a screaming black hole. Screaming in space? I thought in space no one can hear you scream. Well, let me explain. Using a telescope, NASA examined the movements of hot gas in a cluster of galaxies in 2002. Then they converted what they found into a sonification. The sound, how can I put it politely, wasn't appealing, but that's okay. After all, you're able to hear the noise hot gas produces in a cluster of galaxies 250 million light-years away. Hey, how would you like to hear the sound gas produces right here on Earth? Never mind. Sound waves already existed over there in the gas cluster, so experts just rescaled them to the range of human hearing. This is how they converted the input coming from the telescope. The principle is universal. In our atmosphere, we can hear stuff because pressure waves move through a medium like liquid or gas. Sound waves in these galaxies can also move because they're surrounded by gas. What does it have to do with black holes? Well, the thing triggering those pressure waves in the cluster is a giant black hole. To be more precise, it's a supermassive black hole that weighs millions of times more than the Sun. Wow. Experts still don't fully understand the relationship between supermassive black holes and the clusters surrounding them. They only know that these two evolve together. They're interrelated. The cluster feeds the black hole with new material and so on. And in return, the black hole heats the cluster. That's all we know. Now, this made me wonder how large the biggest black holes are. There are 4 types of black holes: stellar, intermediate, supermassive, and miniature. Naturally, the biggest ones fall into the category of supermassive. The largest black hole in the universe we've discovered so far is about 66 billion times larger than the Sun. It's one of the brightest objects in the universe. Astronomers keep scanning space and finding new black holes. But have you wondered when the first black hole was spotted? It was discovered by different researchers independently in 1971. Scientists first confirmed that these objects were formed from the remnants of massive stars. After a black hole appeared, it then consumed all the nearby objects. Here is a quick recap of how these space objects work. Their gravitational force is super strong. Nothing can escape a black hole after crossing the event horizon. Black holes eat everything, just like me. I mean, even light gets trapped inside them. What's even cooler/scarier is that the laws of time and space become distorted there. If you were falling into a black hole, you would realize that time slows down there. Einstein explains this in his famous general relativity theory. In very, very basic terms, time gets affected by how fast you are moving at extreme speeds. NASA has discovered a rapidly growing black hole, but don't worry, the world isn't in danger. This black hole has been in front of the eyes of astronomers this whole time. It's in a region of a well-studied sky field. Astronomers say that this hole formed 750 million years after the Big Bang, the birth of our universe. So why are black holes so bright? Well, that's a bit ironic. When I defined this space phenomenon, I said that black holes were so dense that even light got trapped there. But ask any astrophysicist, and they'll confirm that black holes are among the brightest objects in space. That's because black holes don't exist alone. They sit at the centers of galaxies and are usually surrounded by clouds of hot gas. And these clouds create cosmic auroras around black holes. I must mention, though, that you can't see a black hole directly. What you see is actually the effects it has on its environment. For instance, you can see space objects being ripped apart by a black hole. Remember when the first time ever silhouette image of a black hole was shared with the public in 2019? Proof, you fellas. You wouldn't really see the black hole if there was no orange ring. Why is the ring orange and not green or purple? The dark shadow inside is the shadow of the black hole. The glowing orange of the bright ring in the image isn't the real hue of the gas. I'm a little heartbroken here. It's a representation picked by researchers to depict the brightness of the emissions. A scientist explained that yellow is the most intense emission, red is less intense, and black has little or no emission at all. In the optical range, this ring would likely seem white, perhaps tinged with blue or red. Now, spaghettification is a real word. That's an astonishing ability black holes have. If a giraffe fell into a black hole, it would stretch into a long spaghetti-like strand. On Earth, the giraffe's legs are closer to the center of Earth, so they're more powerfully attracted to the surface than the animal's head. This rule works in the animal's favor on Earth, but would work against it inside a black hole. In a black hole, there's extreme gravity. The closer the giraffe's legs got to the center of the black hole, the more the pull of gravity would stretch them. And the closer to the center the giraffe got, the faster its legs would move. But the top half of the giraffe's body would be farther away, so it wouldn't move toward the center as fast as the legs. Here comes the spaghettification. Can we have meatballs with that? No? Okay. The only difference between a black hole and our sun is that the center of the hole is made of super dense material. It provides the black hole with a strong gravitational field that can trap everything, including light. This is why we can't see black holes. Did you know that, theoretically, you could turn anything into a black hole? For instance, if you shrank the sun to approximately 4 miles across, you would compress the matter inside to an extremely small size. This would make it so dense that our star would turn into a black hole. You could do the same with a planet or even your own body. Is there something called a white hole, or is it just a myth? White holes exist in theory. Hypothetically, they function in the opposite way to black holes. Nothing can enter them. Physicists think of black and white holes as yin and yang, or two sides of the same coin. For them, a white hole looks exactly like a black hole, which makes different things come out of it. But the existence of white holes hasn't been proven yet. And how about wormholes? There are so many movies about black holes and wormholes. How many of them are based on reality, and how much is fiction? Some people believe that black holes function like wormholes. You go inside and exit in another part of the universe. Since we still have a lot to learn and discover about physics, no one can prove this theory is wrong or right. Astrophysics says we need to have a solid theory that unifies general relativity with quantum mechanics. Black holes are among the largest structures in the universe, but there might be tiny specimens. The mass of the smallest black hole we know about is only 3 times greater than that of our Sun. Now, apparently, black holes can vanish. Stephen Hawking developed a theory of Hawking radiation. According to it, radiation decreases the mass and rotational energy of black holes, and ultimately they evaporate. This process occurs very slowly, though, if we're not talking about small black holes. Astronomers have discovered an elusive black hole in the neighboring galaxy. What makes this one special is the fact that it's the first dormant stellar black hole outside of our galaxy. This type of black hole is hard to observe because such holes don't interact much with their environment. They don't emit as much radiation as other black holes. Well, back on Earth, what about sinkholes? Well, different physics. Yet, if you cross the event horizon, your whole car can disappear. Whoops!
An invisible star, a red dwarf, hides 124 light-years away from us. And orbiting this faint celestial body is a planet that could fundamentally alter our understanding of life in the universe. Its name is K2-18b, and this is not its first time in the scientific spotlight. But now the reasons are far more compelling and perhaps historic. A team of astrophysicists from Cambridge, working with data from NASA's ultra-sensitive James Webb Space Telescope, has discovered chemical compounds in the planet's atmosphere that, on Earth, are produced exclusively by living organisms. The substances in question are dimethyl sulfide, DMS, and dimethyl disulfide, DMDS. On our planet, these gases are typically associated with marine plankton and certain bacteria. What they are doing in the skies of a distant exoplanet is still a mystery, but a mystery that might point toward extraterrestrial life. Professor Niku Madhusudan, the lead researcher on the project, calls this the most convincing evidence to date of potential life beyond Earth. If our interpretation is correct, he says, we could confirm it within a year or two. Perhaps the most astonishing part of the discovery is the quantity. The concentration of DMS found in the atmosphere of K2-18b appears to be thousands of times higher than equivalent levels on Earth. If this is not a mistake or observational artifact, we may be looking at an entire world teeming with life. But scientists, including Madhusudan's own team, urge caution. The current data, while impressive, still falls short of the rigorous standards required for a formal scientific discovery.
To claim definitive proof, they need a statistical confidence level of 99.9999%, known as the 5 sigma threshold. At present, the result stands at 3 sigma, or 99.7%, a significant improvement from previous estimates of 68%, but still not enough. Other researchers and independent experts echo the cautious tone. Astronomer Catherine Hamans, for instance, emphasizes that even with reliable data, we cannot say with absolute certainty that DMS and DMDS originate from biological processes. The universe is vast and filled with exotic phenomena. We still don't fully understand what can happen inside such alien worlds. The intrigue surrounding K2-18b isn't based solely on its mysterious chemistry. The planet is roughly 2.6 times the size of Earth, and data suggests it has an atmosphere where ammonia is notably absent, a gas that should be present in a dry, oceanless world. This absence points to a compelling hypothesis: the presence of a vast subsurface ocean. And where there's water, the possibility of life follows. However, alternative scenarios remain. The ocean might consist not of water, but of magma, a revelation that would crush hopes for life. Adding complexity, the planet's very structure is under debate. Some models describe K2-18b as a mini-gas giant with no solid surface. That would render the world utterly inhospitable to life, at least any form of life we currently comprehend. Still, despite all the ifs and buts, the scientific community remains deeply intrigued. The Cambridge team is collaborating with other research institutions to investigate whether the detected molecules could be synthesized through non-biological means in laboratory settings. If such synthesis proves impossible, the case for a biological origin becomes far stronger. Professor Subir Sarkar, another member of the project, is careful with his conclusions, yet he acknowledges that the possible presence of an ocean makes K2-18b one of the most promising candidates in the quest for alien life. His message is simple and clear: watch this space. Cambridge astrophysicist Oliver Shortall, however, brings us back to reality. He reminds us that all of our knowledge about distant exoplanets is drawn from faint threads of light passing through their atmospheres. Interpreting those signals is like trying to read a smudged and half-burnt map, prone to error, to bias, to misinterpretation. Each promising signal could be either a whisper of life or a trick of the cosmic light. Yet the implications are impossible to ignore. Even the slightest probability of a biological origin for these gases elevates the conversation. This isn't just about chemistry. It's about existence. About the possibility that we may not be the only ones looking up into the void. Public curiosity has surged alongside scientific interest. News of K2-18b's chemical profile has lit up headlines, podcasts, classrooms, and conspiracy forums alike. Some hail it as our first real evidence of alien life. Others urge restraint, cautioning against the seduction of sensationalism. But in a world starved for wonder, K2-18b delivers, even if only as a promise. Further missions are already being drafted. Telescopes in space and observatories on Earth are preparing to lock their gaze on this distant enigma. New instruments, refined spectrographs, and smarter algorithms will seek to strip away more layers of the mystery. Every spectrographic fingerprint, every spectral dip in starlight brings us a little closer to confirmation, or recalibration. Science moves not with leaps of faith, but with patient, deliberate steps. And yet, some steps feel bigger than others. When we look at K2-18b, we don't just see another planet. We see a question written across the stars: are we alone? As Madhusudan puts it, decades from now, we may look back at this moment and realize it was the beginning, the dawn of a new cosmic chapter. The moment humanity first saw the glimmer of a living universe beyond the solar system. The discovery hasn't been made yet, but the journey has begun, and that alone is already extraordinary.
Weird, unusual sounds out of nowhere are spreading all over our galaxy, constantly repeating, and it's something we've never heard before. Scientists discovered it in 2020, and it was nothing like any of the other energy signatures they ever studied. Powerful and bright radio signals occurring from time to time, mysteriously disappearing within a day. It doesn't fit the profile of any space body we know. The signal is a bit irritating, and it disappears without a schedule. When scientists tried to match the signal with some other telescopes, it was gone. Low-mass stars sometimes flare up with radio energy, but not here, since they mostly have X-ray counterparts. very dense collapsed stars, like pulsars and magnetars, are also not a choice. The closest solution they got is a mysterious class of objects we know as the Galactic Center Radio Source, GCRT. It's a radio source that brightens and rapidly glows. It decays near the center of our galaxy and could help us unravel the mysteries of the universe. If you had a flying car that could go up at a speed of 60 miles per hour, you'd only need 1 hour to get into space. The moon is a little bit farther, 250,000 miles, which is about 10 times the circumference of our planet. That means a moon trip would be like taking a tour around the globe and doing it 10 times straight, which would take less than 6 months. A trip to Pluto would take over 800 years. Proxima b is the closest Earth-like neighbor we have. It's a small rocky world that orbits the closest stellar neighbor of our Sun. It orbits the star's habitable zone, an area that's far enough from any star to have moderate conditions, not too cold and not too hot for liquid water to at least hypothetically exist. If you tried to travel to Proxima b at a speed of 25,000 miles per hour, which is the speed of the Apollo moon rockets, it would take you over 112,000 years to get there. You might not be able to breathe there. No one knows if Proxima b has an atmosphere. Humans explore the universe all the time, but we can only see around 5% of the matter up there. And Albert Einstein was the first one that realized the empty space is not really nothing. The rest we can't see is actually made up of invisible matter, also known as dark matter. It's about 27%, combined with something called dark energy, which is 68%. If you try to pour water into space, of course, outside of a spacecraft, it would immediately boil away or vaporize. That's because there's no air or air pressure in space. As air pressure lowers, the temperature you'd usually need to boil water at also gets lower. Keeping that in mind, water boils way faster on a mountaintop than, for example, at sea level. There's no air pressure in space, so water could boil at a very low temperature. Scientists believe that there are at least a couple of billion galaxies out there. We don't know the real number, and probably never will, but they tried to calculate it by counting how many galaxies we can see in a pretty small and restricted area of the sky. It may seem as if the universe was filled with stars and a couple of planets here and there, but our home galaxy has at least 100 billion planets. If you fill a balloon with helium and release it, you'll notice it floats very high. It'll go up into the atmosphere, but it won't go into outer space. The higher you go, the thinner the air in our atmosphere gets. Your balloon will rise up until the point where the atmosphere surrounding it has the same weight as the helium inside it. That will happen at approximately a height of 20 miles above the surface, so this is as far as a helium balloon can rise. We don't really know how big the universe is. We can't see its edges, nor do we know if it even has an edge. We use technology to see out to a distance of around 14 billion light-years from our planet. This means we can see around 28 billion light-years in diameter across, starting with the outermost layer of our atmosphere that ends at around 600 miles above our planet's surface. Although the size of the universe is constantly changing and gets bigger through time. Mercury is closest to the Sun, so most people think it's the hottest planet too. Still, Venus is the hottest planet. It's the second planet away from our central star, around 30 million miles farther from the Sun compared to Mercury. Mercury doesn't have an atmosphere, which is like some sort of a warming blanket that helps maintain the heat coming from the Sun. Venus has an unexpectedly thick atmosphere, around 100 times thicker than the one we have. Its atmosphere doesn't let the heat out, it just keeps it, and constantly makes Venus hotter and hotter. Also, it mostly consists of carbon dioxide that freely lets solar energy in. But it's less transparent to lose long wavelength radiations that the warm, heated surface emits. The average temperature there is around 875 degrees Fahrenheit, which is hot enough to melt tin. The maximum temperature on its neighbor, Mercury, is 800 degrees Fahrenheit. in maybe 2 or more billion years, it will be way too hot for life to exist on our precious planet. As the hundreds of millions of years go by, our sun will keep getting hotter and brighter. Eventually, temperatures will be so high, our beautiful oceans will be wiped away. Since they produce 70% of the oxygen we need to survive, there'll be no life without them. All of this means that our planet will simply become a vast desert, something like Mars is today. Pluto, a very distant used-to-be planet, now dwarf planet, is actually smaller in diameter than the entire US. The biggest distance there, from Maine to Northern California, is approximately 2,900 miles, while Pluto is only 1,473 miles across. Pluto is very far, but the edge of our solar system is 1,000 times farther away than this dwarf planet. But astronomers found many space objects orbiting our sun way farther than Pluto, such as Kuiper Belt objects and trans-Neptunian objects. There's also an Oort comet cloud that goes half a light year from Pluto, also 1,000 times farther. A neutron star is really heavy. Just a teaspoon filled with it would weigh 6 billion tons. Neutron stars are something that remain from huge stars that have run out of fuel. The fading star explodes, and its core falls apart, but due to gravity, it forms an extremely dense neutron star. These stars typically have a mass of up to 3 suns, but the radius there is around 6 miles, because this is one of the densest things in our universe, at least that we know about. The universe has a color, and it averages to be some kind of beige, or as they call it, cosmic latte. It also has its own smell that reminds you of seared steak or hot metal. At least, that's something astronauts floating in space have said. If you want to build a spacesuit, get ready to work really hard. It takes 5,000 hours to make it and will cost you $1 million. A really good one will have 11 layers of material and weighs about 110 pounds, and it needs to be comfortable. You'll need more space in there because you grow up to 2 inches when in space. When you're floating around in space, Earth's gravity doesn't have any impact on you. That's why the vertebrae in your spine might expand and relax a little bit, which means you'll be maybe 3% taller. For 6 feet, it's about 2 extra inches. Oh, don't worry, it's not permanent. As soon as you go down to Earth, you'll shrink back down to your normal size within a couple of months. Space isn't the best option if you want to have a conversation with your friend, because up there, sound doesn't travel at all. Molecules there are so far apart that sound vibrations can't reach them, which automatically means they can't vibrate, so we can't hear them. Movies are not accurate with this. No one could hear you screaming in space, too. We kind of live inside our sun. The sun is not just that big hot ball of light located 93 million miles away from us. Its outer atmosphere is way bigger. It extends far beyond the surface we can see. Our planet's orbit goes through its tenuous atmosphere. The evidence is when gusts of the solar wind generate the southern and northern lights. That means, in some way, we live inside the sun. Not just us, other planets too, including distant Neptune. The heliosphere, which is what we call the outer solar atmosphere, extends to about 10 billion miles.
On August 20th, 1977, the most ambitious space mission took off from Earth. The main goal of Voyager 2 was to study the outer solar system up close. It became possible because of a rare alignment of planets. Voyager 2 was supposed to study all the gas giants of the solar system: Jupiter, Saturn, Uranus, and Neptune. Astronomers also hoped it would be able to find and explore the edge of the solar system. Since Voyager 2 was built for interstellar travel, the probe was equipped with a large 12-foot wide antenna. It allowed the spaceship to send the data it gathered back to Earth. During its journey, the space probe discovered a 14th moon of Jupiter. Voyager 2 was the only spaceship to study all 4 giant planets from up close. It was the first human-made object to fly past Uranus, where it found 2 new rings and 10 new moons. Voyager 2 also flew by Neptune and noticed its great dark spot. That's a colossal spinning storm in the planet's southern hemisphere. The storm is the size of Earth and moves at a speed of 1,500 miles per hour. These winds are the strongest ever recorded on any planet of the solar system. In the history of space exploration, only 5 spacecraft have managed to leave the gravitational pull of the solar system. Those were Pioneer 10 and 11, Voyager 1 and 2, and New Horizons. People launch thousands of objects into space. These objects easily overcome Earth's gravity. But the Sun is around 300,000 times as massive as our home planet. That's why its gravitational pull is way more difficult to fight. Even more impressively, Voyager 2 is the second human-made object in history to reach the space between stars after passing through the heliosphere. That's a bubble of magnetic fields and particles produced by the Sun and protecting the solar system. 2 years after its launch, Voyager 2 started transmitting the first images of Jupiter. The space probe provided scientists with much-needed information about Io and Europa, some of the largest of Jupiter's moons. Then the space mission passed by the gas giant itself. The distance between the spacecraft and the planet was around 400,000 miles. That's when the probe noticed some changes in the shape and color of the Great Red Spot. It's an enormous, long-lived storm system, like a hurricane on Earth, but much, much larger. 2 years later, Voyager 2 reached Saturn. It discovered spokes and kinks in some of the planet's rings. While the spacecraft was flying behind and up past the gas giant, it passed through the plane of Saturn's rings. At that time, Voyager's speed was around 8 miles per second. For several minutes, the probe was hit by thousands of micron-sized grains of dust. This kept shifting the probe's direction, and its control jets had to fire many times to stabilize the vehicle. After Voyager 2 explored Uranus and Neptune, it headed out of the solar system. Its instruments were put in low power to save energy. In August 2007, the spacecraft passed the terminal shock. It's the boundary marking the outer limit of the Sun's influence. Here, the solar wind slows down. In the summer of 2013, the probe reached interstellar space. Now, when it comes to sending and receiving signals in space, there are 3 factors you should keep in mind: distance, power, and time. The farther away a spacecraft is, the farther a signal has to travel before it reaches it, and the longer it takes for this signal to catch up with the spacecraft. And when it finally gets there, it's extremely weak. Another problem is that once the spacecraft is launched, it can't be upgraded. It's literally stuck with the technology it was outfitted with. Plus, such spaceships as Voyager 2 are powered by radioactive fuel. When special material radioactively decays, it releases heat that gets converted into electricity. Unfortunately, the more material decays away, the less power the spacecraft has for receiving and transmitting radio signals. Despite this issue, we haven't lost the connection with Voyager 1 and 2. That's because new and more powerful technologies appear on Earth. Signals people send can reach much farther than before. That's why it was possible to stay in touch with Voyager 2, which entered interstellar space in 2018 and has already traveled almost 12 billion miles away from Earth. But in March 2020, the main piece of equipment that allowed scientists to exchange signals with the spaceship was switched off. After the communication with the spacecraft stopped, NASA spent around 11 months upgrading its deep space network and installing new hardware. The DSN is an international array of huge radio antennas that help astronomers on Earth communicate with interplanetary missions. These antennas are located in California, Madrid, and Canberra. The one used to keep in touch with Voyager 2 is a 230-foot wide dish in Canberra. This is the only equipment that can send commands that can reach the probe. This antenna, known as DSS-43, started operating in 1972, 5 years before Voyager 2 and 1 were launched. At that time, it was only 210 feet across. Since then, the dish has received a lot of repairs and upgrades, but these 11 months were the longest the antenna was offline. In October 2020, the antenna was finally ready for a trial after all the upgrades and repairs. The mission operators sent a set of commands to Voyager 2, and after many months of radio silence, the spacecraft returned the signal. The probe confirmed it had heard the call. After that, the spacecraft carried out the commands. While the dish was offline, the mission operators could actually receive scientific data and health updates from Voyager 2. Astronomers kept getting data from interstellar space, the region outside the Sun's heliosphere, but they couldn't send any commands to the probe since it had traveled too far away from Earth. The upgraded antenna received 2 new radio transmitters, and it was done just in time. One of the transmitters, that was used to communicate with Voyager 2, hadn't been replaced in almost 50 years. The antenna also got new cooling and heating equipment and other electronics necessary to support the advanced transmitters. Now, a curious thing about the Deep Space Network is that its radio antennas are positioned in a very precise way. They're spaced equally around the globe. This way, almost any spacecraft can stay in touch with at least one facility at all times. But Voyager 2 is an exception. In 1989, it made a close flyby of Triton, Neptune's moon. It was the only close encounter people had with the 8th planet of the solar system and its moon. By the way, Triton is the largest known object that is believed to be born in the Kuiper Belt. That's a donut-shaped ring around the Sun full of icy objects. Voyager 2 discovered Neptune's ring system and its tiny inner moons. The probe also gathered a lot of amazing information about Triton. For example, it became clear that the moon is covered in cryovolcanoes. Instead of spewing molten rock, these volcanoes spit ice consisting of water, ammonia, and methane. When the New Horizons spacecraft flew past Pluto more than 25 years later, it discovered the same phenomenon on the dwarf planet. Anyway, to make this detour, Voyager 2 had to travel over the gas giant's North Pole. But this changed the probe's trajectory, deflecting it southward relative to the planes of the planets. Since then, Voyager 2 has been moving in that direction. And now, the spacecraft is so far away that it's out of reach of the radio antennas in the Northern Hemisphere, those in Madrid and California. This makes DSS-43, which is located in the Southern Hemisphere, the only dish powerful enough in broadcasting just the right frequency to send commands to Voyager 2. Voyager 1, the probe's faster-traveling twin, didn't change its trajectory. After passing by Saturn, it took a different path. That's why now it can easily communicate with the 2 facilities in the Northern Hemisphere. The upgrade the Canberra Deep Space Communication Complex has gone through can also benefit other space missions. For example, the Mars Perseverance rover that landed on the Red Planet on February 18, 2021. The dish will also be crucial for exploring other planets and the Moon. A new super-Earth has been spotted by astronomers, and it's quite intriguing. This planet, called TOI 715b, is about 1.5 the size of Earth, which is why it's called the super-Earth. It's also relatively close to us in space terms, only 137 light-years away. For comparison, most exoplanets are hundreds of light-years away, and all the interesting stuff, like black holes and nebulas, are usually more than thousands of light-years away from us. So, could it be habitable? The habitable zone is an estimate of where a planet might have the right conditions for liquid water. This is what we call some distance from the star, where the temperatures on the planet should be okay-ish, and water should stay liquid on its surface. It's not super precise because it depends on a bunch of factors like the type of star, how reflective the planet is, its size, and so on. Also, just being in this zone isn't enough for water to actually be there. The planet also needs the right kind of atmosphere and a few other things. So, we invented a stricter definition in 2014, the conservative habitable zone. It's a more precise term defining the best candidates that have liquid water. Otherwise, we get too many potentially habitable planets that are not actually habitable at all. The CHZ is based on how much energy a planet gets from its star compared to Earth. If a rocky planet gets between 40 to 85%, it's considered to be in the CHZ, no matter how far away it is from its star. These planets have a higher chance of being habitable. And yes, TOI 715b is located there. This super-Earth orbits the M-type star, also called red dwarf. It's a star that's much smaller and cooler than our Sun, about a quarter of the Sun's size and mass. But if the planet is located in the habitable zone, it's actually a better option for life. Red dwarfs live much longer than our sun, a yellow dwarf. This also means that they have more time to form little creatures on their planets. And this red dwarf really is older than our star. Our sun is 4.6 billion years old, and this star is 6.6 billion years old, give or take a few hundred million. It doesn't have much magnetic activity, so it's not dangerous. It doesn't flare up like younger red dwarfs. These flares can be super strong and might even hurt planets by taking away their atmospheres. Although some planets around it do have thinner atmospheres, it seems like this red dwarf has already gone all out. These red dwarfs are where we're looking for planets that could support life right now. Our super-Earth is really close to its star, zooming around it in just 19 days. Since the star is small and the planet is so close, the planet passing in front of its star happens a lot and looks really clear. This makes it easy for telescopes like the James Webb to study its atmosphere without needing too much time. Now, speaking of the James Webb Space Telescope, it's bringing us into a new era of understanding distant planets beyond our solar system. Imagine being able to see what gases make up the air on a planet millions of light years away. James Webb will help us to find worlds that could support life. Right now, it's trying to figure out whether TOI 715b has an atmosphere. If it does, its atmosphere might be easier to spot compared to a planet that's drier and denser. And then we might get even more height because it would look like a good place for life. On top of all that, there might be another planet in this system, also in the habitable zone. We're not sure whether it's really there, it's just a candidate with a crazy name. But if it turns out to be real, it would be about the size of Earth. Also, it would be the smallest planet in the habitable zone ever spotted by the TESS telescope. Now, another cool thing about TOI 715b is that it cannot just have water on it, but be an entire water world. An ocean planet is a type of planet that has an ocean covering its surface or has subsurface oceans. They might not have much dry land because the water can cover everything. Sometimes the entire planet can be covered in other liquids, like lava or ammonia. When it comes to planets outside our solar system, we can't see surface water directly with our current technology. Instead, scientists look for water vapor in the atmosphere as a hint there might be liquid water below. And of course, we wonder if these planets can have life, hopefully not in the form of Leviathan-like monsters. Our models show that planets with oceans might be pretty common in our galaxy. This means there could be lots of ocean worlds out there waiting to be discovered. But the most important part about TOI 715b is that it's in the so-called small planet radius gap. If we give the planets a lineup, there will be those that are bigger and smaller than Earth. But there's a sudden gap in planets that are about from 1.5 to 2 times bigger than ours. Where are they? This gap is interesting to scientists because it tells us something about how planets form and change over time. It's not that planets don't form in this size range. They actually start off larger and then lose some of their mass, like a balloon gradually deflating. Perhaps it happens because of how they orbit their stars, with stars blowing away some of their mass as they dance around it, as our sun does with gas from comet tails. This gap holds a lot of mystery, and planets, like our new super-Earth, are clues that could help us unravel it. We aren't sure whether it exists around red dwarfs. Maybe it's a gap in how dense these planets are, rather than in their actual size. So studying our discovered planet is even more interesting. It'll help us learn more about distant stars and their planets. Now, I mentioned TESS a while back. NASA's TESS, Transiting Exoplanet Survey Satellite, has been in space for 6 years now and has been incredibly successful. NASA launched TESS because we already found over 5,000 planets orbiting other stars, mainly thanks to the Kepler telescope. But Kepler mostly found large planets, not necessarily like Earth. We decided to focus TESS on finding smaller Earth-like planets around nearby bright stars, making them easier to study with future telescopes. Here's how it works. The camera observes stars and looks for changes in their brightness. If the brightness suddenly drops for a while and then gets back, It could mean there is a planet passing in front of it. But stars can dim for other reasons too. For example, flaring up or having dark spots on their surface, which is why we need to be careful with this data. TESS shows us the size and orbit of these planets. Then ground telescopes help determine their mass. With these three parameters, we can figure out what the planets are made of and if they're rocky like Earth or gassy like Jupiter. Yeah, you want to avoid Jupiter after taco night. One example of TESS's discoveries was the TOI 700 system. There, it discovered its first ever Earth-like planet, TOI 700d. This exoplanet also orbited a red dwarf, and it's even closer to us, about 100 light-years away. Unfortunately, it's unlikely to be habitable because the temperatures there are crazy. Another big discovery was made in the AU microscopy system. TESS discovered a planet about 4 times the size of Earth and another nearly 3 times Earth's size. This system has become a key area for studying how stars and planets form and change over time. TESS has also spotted a variety of other exciting finds, including supernova, hot worlds, and so on. And as it enters its 6th year, we can only expect more exciting findings to come. Here's our home, good old Earth. Let's zoom out, way, way out, until we're roughly 100,000 light-years away. Okay, from here, it's possible to see our entire galaxy, the Milky Way. It looks like a huge shining disk in the dark. But new models suggest that what we can't see is that this bright disk is actually floating inside a giant pancake made of the mysterious dark matter. Ooh, pancakes. I'm getting hungry. Want to learn more? Well, follow me. The Milky Way is like a colossal spinning pinwheel in space. If you step outside on a clear night and get away from city lights, you'll see a bright milky band stretching across the sky. That glowing stripe is our galaxy, and we're looking at it from the inside. We're positioned on one of the outer arms, gazing toward the bright packed center. Our galaxy has close to 400 billion stars, and our sun is just one ordinary star floating in that huge crowd. Yet, on a universal scale, our massive home is basically a single grain of sand on an endless beach. The observable universe spans over 93 billion light-years across. It holds billions of other galaxies. That's so many zeros, it's worth talking about them. So let's zoom back in. What does it mean to be sitting on a giant flat slab of dark matter? Well, regular matter creates everything we can actually look at. It builds glowing stars. It forms rocky planets. It even makes up your own body. Regular matter interacts with light, so our telescopes can measure it. Dark matter is the opposite. It is invisible. It does not reflect light. And as far as we can tell, it doesn't interact with light in any direct way. Scientists know that this hidden material exists because of what gravity gives away. The Milky Way spins at roughly 130 miles per second. At that speed, the outer stars should literally fling right off into empty space. They should fly away like water droplets spinning off a wet tennis ball. The gravity provided by all the visible stars is simply not strong enough to keep the galaxy intact. There has to be far more unseen mass creating extra gravity. That hidden mass is dark matter. It accounts for about 85% of all the material in the universe. It acts like an invisible skeleton keeping galaxies together. Without it, the Milky Way would rip itself apart. But dark matter is usually imagined as a giant round halo around a galaxy, almost like an invisible cocoon. This recent study suggests that on a much bigger scale, the Milky Way is sitting inside a broad dark sheet, something more like a pancake than a ball. Our region has 3 clues. Nearby galaxies form a flat structure. Huge voids sit next to it. And the local expansion looks oddly tidy. The study says those may all be parts of the same bigger shape. According to the model, the Milky Way and its neighbors may sit inside a much larger pancake-shaped concentration of dark matter stretching tens of millions of light-years, more like a broad, spread-out slab of invisible mass. That hidden mass could shape the whole neighborhood. It could help pull galaxies into a flatter arrangement instead of letting them spread more evenly in every direction. It could also help create emptier regions above and below that layer. It may even explain the smooth motion. If nearby galaxies are moving inside a much larger structure, then their paths are being guided by that structure. The quiet Hubble flow may not be a coincidence. It may be a clue. Now, astronomers did not see this dark sheet directly. They worked backward from motion. They measured where nearby galaxies are and how they move, then asked what kind of hidden mass would produce that pattern. The answer was not a blob, not a sphere, not a random cloud. It was a flattened structure on an enormous scale. So, how do you find a giant invisible structure you can't see at all? Well, you look at what it does. Scientists tracked how isolated galaxies near us are moving and used them like bright markers in the dark, revealing how unseen gravity is tugging on them. Then they ran simulations to test what kind of hidden structure could create that pattern. A big invisible sphere did not fit very well because gravity from a round cloud would pull things inward more evenly. A broad, flat shape matched the observations far better. This flat structure reshapes how we explain our part of the universe. It acts like a huge invisible tabletop where galaxies tend to line up. Because of this, the space right above and below is empty. It explains why we have these giant uninhabited zones of space nearby. This pancake is like a hidden framework that keeps our corner of the universe organized. And this hidden structure does not just shape where galaxies sit. It may also be moving as part of a larger cosmic flow. The entire dark matter pancake is hurtling through space. We are surfing on a cosmic wave through space at a ridiculous speed. The whole flat sheet is being dragged toward a dense region of space astronomers call the Great Attractor. It is the gravitational anchor of our local universe. Basically, it's a dense, packed region containing tens of thousands of other galaxies grouped closely together. All those galaxies combined create an immense amount of mass. That weight generates a gravitational pull so intense it bends the fabric of space. It forces everything within hundreds of millions of light years to fall toward it. It acts like the low point in a giant cosmic landscape, pulling our entire dark matter pancake with it. The wild part is that we still can't see this structure. The Great Attractor hides behind a thick glowing band of stars at the center of the Milky Way. Astronomers call this blocked area the Zone of Avoidance. Ooh, good nickname. Trying to look at it is like trying to admire a mountain through a completely mud-splattered car windshield. We know a massive cluster of galaxies is pulling us, but the dust and gas of our own galaxy block the view. Our dark matter pancake is actually just a tiny crumb inside a much larger structure. We belong to a colossal cosmic continent called Laniakea. That word means immense heaven in Hawaiian. It stretches 520 million light-years wide. It contains the weight of 100 million billion suns. The Great Attractor is the gravitational heart of this supercluster. Our flat neighborhood is sliding down a giant invisible funnel toward that center. The quiet Hubble flow keeps most of our distant neighbors drifting away peacefully. But there was supposed to be one major exception: the Milky Way crashing head-on into Andromeda. For years, that future collision sounded almost guaranteed, a huge galactic wreck. Stars flung around, two giant spirals blending into one monster galaxy. Except now, that prediction looks a lot shakier. Newer studies suggest the odds of a crash in the next 5 billion years are actually tiny, and even over 10 billion years, it is closer to a coin toss. So the universe may be canceling one of its biggest predicted disasters. So the discovery of this invisible flapjack changes how we look at the night sky. We used to believe glowing stars told the whole story. Now we know they're merely the sprinkles on top of an invisible pancake. The real architecture of the universe is mostly hidden from our eyes. Now, if all this talk about pancakes made you hungry, me too, here's a fun bit of trivia for the end. The famous Milky Way chocolate bar was not actually named after our galaxy. The creators named it after a hugely popular malted milkshake from the 1920s. They wanted to capture the exact flavor of a sweet diner drink in a solid candy block. But that's not the only coincidence. The company producing the Milky Way is called Mars. That title has absolutely zero connection to the red planet next door. It was simply the last name of the company's founder, Frank Mars. Since we now know our huge galactic home rests right on top of an invisible pancake, let's hope somebody actually gets inspired to invent a pancake dessert. So right now, there's a high-stakes chase happening in deep space. A Japanese ship is flying at full speed to hunt down something that technically shouldn't even exist – a dark comet. Now these rocks are strange. They aren't asteroids, but they aren't comets either. They're this strange mix of both. Dark comets might hold the secret to how water first got to Earth, but they could also be a massive threat to our planet. Now we are getting closer to finding out how dangerous they really are. 5 years from now, a spacecraft named Hayabusa 2 is set to reach a dark comet. The plan is to get really close, maybe even land, and just start collecting a ton of data. The funny thing is, this whole chase happened by total coincidence. So, Hayabusa 2 is basically Japan's cosmic treasure hunter. Launched back in 2014, this spaceship flew millions of miles to reach a dark ancient asteroid called Ryugu. It finally got there in 2018, and that's when Hayabusa 2 deployed 2 rovers and a small lander onto the surface. Then, a half a year later, it blasted the asteroid's surface with something called a kinetic penetrator to collect samples. The spacecraft came back in 2020. It swooped by Earth to drop off a capsule holding the asteroid sample. Thankfully, it all worked out, and that capsule gave scientists important clues about the origin of water on Earth. But Hayabusa 2 still had some fuel left, so Japan decided to extend its mission and send it back to deep space. This time, to follow an asteroid called 1998 KY26. And by a huge coincidence, scientists later found out this space rock was actually a dark comet. Yep, just like the famous Oumuamua, that strange object that made headlines because it looks like an extraterrestrial spaceship. This was the first known object that came from outside our solar system, and it was weird. Its speed and path around the Sun didn't match a typical asteroid, but it also didn't have the bright tail or nucleus we normally associate with comets. So, scientists started looking for more space rocks that acted the same way, and they actually found 14 of them. They basically fall into 2 groups, the outer dark comets and the, wait for it, inner dark comets. The outer ones are these massive objects with really stretched out orbits, and they probably come from the outer solar system. By that, I mean way out past the asteroid belt. That's the neighborhood where you find the 4 giant planets, Jupiter, Saturn, Uranus, and Neptune, along with a ton of smaller icy rocks, moons, and the Kuiper belt. Then, we've got the inner dark comets. These are much smaller. They have orbits that are almost perfect circles, and they hang out in the inner solar system. That means they're a lot closer to Earth. But the one thing these rocks have in common is that they move like comets, but they don't look like them. Normally, when a regular comet gets close to the Sun, it heats up and releases gas and dust. That's what gives it that bright cloud and long tail we normally see. But dark comets don't have a visible tail. If we look at them through a telescope, they look exactly like regular asteroids. But they don't move in normal, predictable orbits. As dark comets travel through space, they slightly speed up or shift in ways that gravity alone just can't explain. So, something else has to be pushing them. Scientists think they might contain ice, and if that's true, it's a massive deal. Because if ice is common on these little rocks flying near Earth, they might actually be the reason our planet has water today. That's one of the biggest mysteries we're still trying to solve. And that Japanese mission I mentioned earlier might actually provide some answers. Right now, Hayabusa 2 is out in deep space, and it's on track to catch up with that dark comet by July 2031. Now, since the spacecraft already pulled off that first landing on Ryugu, you'd think we'd be like, okay, this next one will be a piece of cake. But that's not the case at all. I mean, just look at the difference between them. This is Ryugu, and this is KY-26. Landing on something that tiny is much, much harder. Now the team is a little worried, because when they first planned this mission, they had no idea this dark comet would be so small. And here's the problem. The smaller these things are in space, the faster they spin. According to the first measurements, KY-26 was supposed to be a lot bigger, about 98 feet across, and spinning once every 10 minutes. But new telescope observations show it's actually only 36 feet across, and it's spinning so fast that it does a full rotation every 5 minutes. That makes the mission way more interesting, but also a lot more challenging. The truth is, the team really doesn't know what to expect or what it's going to look like. Now, Japan isn't alone in this race, though. The European Space Agency is also planning to launch their own mission to look for similar comets. Sometime in late 2028 or early 2029, they plan to launch the Comet Interceptor. The idea is to visit a comet coming straight from the outer edges of our solar system. See, if they can catch a comet that has never passed near the Sun before, it'll give us a perfect look at the raw materials from the very beginning of our solar system. Basically, they want to catch more interstellar visits, just like Oumuamua. These objects are really tough to study since we only spot them when they are already close to the Sun. By the time we see them, there's just no time to plan and launch a whole mission. So this time, they're doing it a little differently. The Comet Interceptor is going to be parked out in space ahead of time, in a spot known as the second Lagrange point. This is an area located about 1 million miles directly behind Earth, if you're looking from the Sun. Out there, gravitational forces from the Sun and Earth and the orbital motion of a body balance each other out. It lets a spacecraft basically hover in a stable position right alongside Earth as we orbit the Sun. The Comet Interceptor will just stay parked right there, waiting. Then, the day our telescopes down here spot the perfect comet passing by, scientists will map out the intercept location. The main spacecraft will fly out and release 2 smaller probes so they can observe the comet from multiple angles at the same time. As we're finally getting closer to dark comets, 2 big fears come to mind. First, what if they aren't comets at all? I mean, what if they are artificial, like some kind of extraterrestrial tech? This idea was brought up by Harvard astrophysicist Avi Loeb. He says some of the newly found near-Earth dark comets are the perfect size to act like a mothership. Because their gravity is so weak, dropping off smaller probes would be incredibly easy. If those probes were released at just the right time, they could be sent straight toward Earth. And if they had their own propulsion, they could slip right through our atmosphere without even making a big fireball. So, who knows? Maybe these rocks are actually high-tech gadgets from another interplanetary civilization. Then, there's the second concern. Research suggests that up to 60% of near-Earth objects could actually be dark comets, which means they aren't rare at all. And if they are that common, they could be a massive, untrackable danger to Earth. They're small, fast, and really hard to spot. But most importantly, they don't behave like their regular asteroid and comet cousins, which makes them completely unpredictable. Well, at the end of the day, if we want to keep Earth safe from these invisible threats, we definitely need to figure out exactly what these dark comets are and where they're heading. But it's not just about planetary defense. Cracking this mystery could completely rewrite the playbook for how we explore deep space, and it might even kick off a whole new era of asteroid mining. The universe is hiding these things right in our own backyard. Now, it's a race to catch one before it catches us. The only life that we are certain about so far in the entire universe is on planet Earth. Whether that life is intelligent is, let's say, arguable. But anyway, it's not surprising that we're tirelessly searching for life on other planets. So far, they've discovered more than 4,000 of them. But what's even cooler? NASA has compiled a new list of 24 planets that aren't just Earth-like, they're better. The conditions on them are so good that they're more comfortable than on our planet. So let's examine some of them. KOI 5715.01. Let's be coy, shall we? This wonderful planet is in the constellation Cygnus. And why is it so wonderful? Well, our Sun is a yellow dwarf. And sorry, Sun, even though you're not bad at supporting life, there are some stars that can do it better. Nothing personal. The planet Koi 5715.01 orbits near an orange dwarf. Orange dwarfs are stars slightly smaller than our Sun and have a little lower luminosity. Did you like the alliteration there? Anyway, don't worry, it doesn't mean we're going to live in complete darkness. In fact, if the planet is found closer to the Sun and it has a thicker atmosphere, it may even be lighter and more colorful than on Earth. Now, our Sun has a very short lifespan. Right now, it has 7 to 8 billion years left to live, a little longer than Earth's age. But orange dwarfs can live from 45 to 70 billion years. This is great not only because we'll be able to hang out on this planet longer, but also because the planets around these stars have more time to form life. Now, ideally, we would need to find a planet next to an orange dwarf that is about 7 billion years old. It's very likely there will be at least some organisms there. Koi 5715.01 is about 5.5 billion years old. Yeah, it may not seem mature enough, but that's okay, neither do I. Our Earth is a billion years younger, and that didn't stop us. The planet is quite close to its star and is in a habitable zone. 1 year there lasts 190 days. Imagine going to elementary school and already getting a driver's license. It's almost 2 times larger than the Earth. The average temperature there is 52 degrees Fahrenheit, which is slightly less than ours, 57. But it mostly feels warmer there because strong gravity helps it hold on to heat in the atmosphere longer. It's a little too far away though, like 3,000 light-years from Earth, which is about 18 quadrillion miles. Yep, better bring a really big lunch with you. Koi 3010.01. This planet is found next to the star Koi 2010. This planet sounds like a very pleasant world. The average temperature on this planet is 67 degrees, so a little warmer than ours. But that's a good thing. Scientists believe that on a perfect planet, the temperature should be just about 10 degrees hotter than on Earth. The more heat there is on the planet, the more comfortable it is to live there. Also, the higher chances of developing life. The radius of this planet is nearly 1.5 times larger than Earth. There's some atmosphere, although we're not yet sure about its composition, but it's probably like the Earth's. Scientists think that we'll find an ocean there, and it can cover up to 60% of the surface, which is also cool. In a perfect world, water and land should be distributed more evenly than on our planet. A little more land means a little more territory and resources, right? But listen, this planet is actually very similar to the Earth. The semblance is so striking that scientists believe we have an 84% chance to find life there. Of course, not necessarily an intelligent life, but at least some animals. Wouldn't that be cool? Now, what do you think they could look like? Very Earth-like planet, but with stronger gravity. Well, if someone lives there, they're probably big but have a small height and strong little legs. Sounds adorable and scary. But we won't be able to find out the truth anytime soon. So far, for us, these planets are microscopic dots in space. We only have some dry, boring data about them and don't even know what they look like. We'll have to wait until we can find a way to get closer to these planets. Kepler 186f. This is also one of the best candidates for having life. This rather cute planet was nicknamed the Earth's cousin because it does have a strong resemblance. Anyway, these two planets are like sisters, not twins. Kepler 186f rotates near a red dwarf. Red dwarfs are stars even dimmer and smaller than orange dwarfs. Yeah, they'll also live for a very, very long time, but their luminosity is also quite low. However, Kepler 186f is closer to its star than we're to our Sun, so it shouldn't be too dark there. Well, at least not night-like dark. The sky on this planet is sure to be an unusual shade of red, like sunsets on Earth. What do you think? Would you like to live on a planet with an eternal sunset? The size of this planet is about the same as Earth. Not bad, not perfect. Why so? Because the coolest planets are those that are bigger than Earth and have stronger gravity. Now you'll probably say, but wouldn't it be harder to walk there and even harder to get out of bed on Monday? Of course. But on the other hand, this planet will pull the atmosphere better. The atmosphere will be thicker and denser. This means more protection from the scary space stuff, more oxygen, and more heat. Not to mention the fact that the bigger planets have more space to settle. Awesome, right? But of course, the Earth's size is also an excellent choice. Another cool fact is that the tilt of Kepler 186f is about the same as ours. It means that there should be stable seasons and a normal day-night cycle. Do you know how important the tilt of the planet is? Let's look at Mars. Mars is also, in fact, found in the habitable zone of our Sun, but its tilt is very unstable, and as a result, the entire ocean that could have been on it once now completely dried up. Today, it's just a red desert, and there's no life there. At least not as far as we know, but you see how important these tiny details are? This planet is also quite far away from us, 490 light-years. That's about 3 quadrillion miles. So yeah, we're just going to keep waiting for intergalactic travel. Kepler 62e and 62f. These planets were called the most Earth-like before we discovered Kepler 186f. They're very comparable to our home. Kepler 62e is about 1.5 times larger than Earth, and Kepler 62f is just slightly smaller than that. They're located in the constellation Lyra, which is about 1,200 light-years away from us. They both also orbit a red dwarf. 1 year on Kepler 62e lasts about 122 days, even less than on that first planet we talked about. Scientists believe that both 62e and 62f are sort of water worlds, warm places mostly, or even completely covered with water. If there is land there, it's probably just some islands. A world consisting entirely of islands. A fantasy dream for some, think Hawaii, and a nightmare for others, think Megalodon. But if you're a fan of ancient marine animals, just imagine how gigantic they could be there. Still, there are many things we don't know about this planet. Does it have a surface? What about its composition, density? One day, maybe we'll be able to answer these questions. And so, that's it for the super-Earths. Of course, the original list is much longer, and you can go check it out on the internet. Now, the best thing about all this is that these are planets that are better than the Earth. But we also know thousands of other exoplanets that are just close enough to ours. And the odds are, a few of them have at least some form of life. But they're very, very far away, so we have no way to check it out right now. Perhaps, down the road, we'll find some cool creatures on many of them. Saturn's rings. Impressive, right? But look closer. They're crooked. Actually, the whole planet is tilted by nearly 27 degrees, which is way more than it should be. Look at its neighbor, Jupiter, for example. It has a tilt of only 3 degrees. So, what happened to the Lord of the Rings? A new study suggests that Saturn used to have a huge extra moon. Yeah, besides the other 274 it currently has. But who's counting? Millions of years ago, that space rock might have crashed straight into Saturn's largest moon, Titan. The collision was so massive that it could have knocked the planet off balance, leaving it even more tilted than before. This extra moon hypothesis is a pretty good one, but to fully understand it, we first need to look at previous theories on why Saturn is tilted in such a strange way. Theory number 1. Blame it on Neptune. Poor guy, this planet is about 1.8 billion miles away, but he ended up becoming the main suspect. For years, astronomers believed Neptune's gravity slowly pulled Saturn over onto its side over billions of years. They thought the two planets were locked in something called orbital resonance that happens when two moons or planets sync up and start pulling on each other in a regular rhythm. Well, here's the thing. A planet's orbit is massive and carries a huge amount of energy, while the way a planet spins is much, much weaker. So, when you lock these two motions together, I mean Neptune's orbit and Saturn's spin, it's Saturn's spin that's going to change and end up tilting. That's the power of orbital resonance. But then, Cassini happened. Back in 1997, NASA launched this spacecraft to explore Saturn and its icy moons. Cassini stayed out there for 13 years, and it shared some really interesting discoveries, including the fact that, nope, Neptune is not our guy. Cassini's data showed that the two planets aren't exactly in sync, so that couldn't explain Saturn's crooked posture. Something was missing. But what? That leads us to theory number 2. It's Titan's fault. Poor guy, he was just there, hanging out as Saturn's largest moon, when suddenly he became suspect number 2. Okay, to be fair, it's more like Titan is the leader of the gang, but the other moons are helping out too. Two scientists from France came up with this theory in 2021. Back then, we already knew that Titan and the other moons were moving away from Saturn. But their observations showed this is actually happening much faster than we thought, at a rate of about 4 inches per year. Yeah, really. Eventually, Titan could even be kicked away from Saturn's orbit entirely. And this whole process actually messes with the way Saturn leans. As the moons drift further away, the planet just tilts more and more. This explains why Saturn is still actively leaning today. In fact, over the next few billion years, the planet's tilt could more than double. Well, that's all pretty interesting, but it doesn't explain one big mystery. Saturn wasn't always that crooked. Some scientists believe that for over 3 billion years after the planet first formed, its lean was actually pretty small. So, something must have happened to change all that. Something big. That's how we got to theory number 3. It's Chrysalis's fault. And again, poor guy, this hypothetical moon might not have even existed, and we're already blaming it. Back in 2022, scientists came up with an idea about a lost moon called Chrysalis that vanished about 160 million years ago. This theory says Chrysalis orbited Saturn for billions of years, helping keep the planet in sync with Neptune. But then, things took a turn. As the moon spiraled inward, Saturn's massive gravity didn't just pull it in, it literally ripped the moon to shreds. Losing Chrysalis's weight and its gravitational pull was like a cosmic kick. It broke Saturn's old connection with Neptune and knocked the whole planet over on its side. In other words, its disappearance could be the reason why those two planets aren't perfectly aligned anymore. Now, even though the moon's solid body is gone for good, its remains didn't just vanish. They flattened into one of the stunning rings we see today. I mean, the exact same thing that tilted the planet also gave it its most famous feature. So, basically, Saturn's famous ring system used to be a moon. Well, how cool is that? Anyway, scientists decided to test this out. But when they recently ran some simulations to see exactly how it all happened, they found a problem. In most of those versions, Chrysalis didn't actually hit Saturn. Instead, it crashed into the megamoon Titan and merged with it. But Titan wasn't Titan back then. There might have been an earlier version of Titan that was a lot more massive than Chrysalis was theorized to be, about 4 times as big. Here's what the team thinks really happened. If we go back 400 million years, Saturn looked completely different than it does now. There were no rings, and it had a different set of moons than the ones we see today. Back then, 2 of them were huge. Let's just call them Moon A and Moon B. At some point, Moon A's orbit shifted and got locked into what's called a 2-to-1 resonance with Moon B. Basically, that means for every one time Moon B went around Saturn, Moon A went around twice. That rhythm caused Moon A to start moving inward pretty fast. Eventually, the inevitable happened. They slammed into each other. That collision ended up doing 2 main things. First, Moon A was pretty much destroyed. A huge chunk of it crashed onto the surface of Moon B, while the rest turned into a giant cloud of debris. Eventually, all those leftover pieces clumped back together into one piece, which became the current moon, Hyperion. The theory actually explains why Hyperion isn't a perfect sphere. It's shaped more like a potato. As for the rest of it, the part of Moon A that hit Moon B merged right into it. Together, they formed the version of Titan we know today, a massive icy moon that's bigger than the planet Mercury. Now, this merging process might also be what created Saturn's rings, maybe about 100 million years ago. As Titan's orbit expanded, it messed with some of Saturn's inner moons, shaking them up until they eventually smashed into each other. Some of that leftover debris stayed behind and became the rings we see today. But we can't say for sure if that's exactly how it went down. mostly because we still don't know how old Saturn's rings really are. So not every scientist is totally sold on this theory yet. Take NASA researcher Linda Spilker, for example. She says this study makes a really strong case that Hyperion and Saturn's rings actually showed up long after the planet itself was born. But the truth is, the rings could be much older than that. And if that's the case, the timing for this theory really doesn't line up. That means we'll have to wait for more proof before we can say for sure. But the answer might be coming soon, thanks to NASA's $3 billion Dragonfly mission. And the whole idea is to explore Titan up close. This is a spacecraft about the size of a Mini Cooper that works a lot like a high-tech drone with 8 rotors. It's scheduled to launch in 2028 and should arrive at Titan by late 2034. Once it gets there, it's going to spend about 2.5 years exploring different spots all over the Moon. Since it has propellers and landing skids, it won't be driving on the ground like a rover on Mars. Instead, Dragonfly will travel by air. It'll take off vertically, fly to a new location, and land again, basically hopping across the Moon. The mission might finally give us the answers we need. Dragonfly could test this theory by looking for geological or chemical signs of a huge crash between 2 moons a long time ago. And if it finds them, bingo! One of Saturn's greatest mysteries will finally be solved. Now, think about the vastness of the universe. Our galaxy contains between 100 and 400 billion stars. Many of them can potentially host planets. Many of those planets might have water in them and be capable of supporting life. And this is just the Milky Way alone. What's the likelihood of other intelligent civilizations existing out there? Well, there's a famous formula called the Drake equation. It's a mathematical tool to guess how many civilizations from outer space might be able to talk to us in our Milky Way galaxy. It was made by a scientist named Frank Drake in 1961. Here are the variables in it. N is the number of civilizations we could potentially talk to in our galaxy. R star is how fast new stars are born in our galaxy. F sub p is the fraction of stars with planets around them. N sub e is the average number of planets around each star that could support life. F sub L is the fraction of those planets where life might actually start. F sub I is the fraction of planets with life that could become smart civilizations. F sub c is the fraction of smart civilizations that send signals into space. And L is how long those civilizations keep sending signals. Of course, we won't get an exact number like this. It's more like an educated guess, and we don't have any answer to that. But based on at least some information we know, there might be around 100 million worlds where life should have evolved. But if that's the case, then why haven't we met or heard from anyone? This is called the Fermi paradox. It's named after the famous physicist Enrico Fermi. He asked a simple but very important question: where is everybody? Our universe should be filled with chatty extraterrestrial beings, advanced civilizations, and spaceships zipping around. Yet, when we look up at the night sky or listen with our radio telescopes and antennas, it's eerily quiet. All we get is the so-called Great Silence of the universe. Scientists from Oxford University's Future of Humanity Institute are trying to answer this question. And they're not the only ones. A group called METI, for Messaging Extraterrestrial Intelligence, organized a workshop in Paris in 2019 to explore this mystery. The workshop brought together experts from various fields, like astrophysics, biology, psychology, and so on. One of the ideas discussed is called the zoo hypothesis. It suggests that perhaps other civilizations do exist, but they're simply not broadcasting their presence. Maybe they know that making direct contact with us could be risky for both sides. So they're intentionally avoiding us because they're watching us like observing a zoo. They could be using advanced technology we can't detect. There are also some optimistic explanations, like time delays. Space, as you know, is unimaginably big. The time it takes for signals or information to travel across the universe is enormous. It's possible that other civilizations exist, but their signals haven't reached us yet, or ours haven't reached them. But some explanations aren't very optimistic. Like, some scientists think Earth might really be unique. Maybe the conditions that led to life and intelligent beings are so incredibly rare that there are no other planets like ours. Scientists point out that there are many planets similar to Earth, and some are much older. This means there should be plenty of planets where life could evolve. Recent research also suggests that life might be way more resilient than we thought. And, well, while it increases the amount of life existing out there, it also increases the chances that intelligent life doesn't last very long. It might destroy itself before it can spread to other parts of the universe. This is a concerning idea for the future of humanity. The researchers also considered that many planets might be at a similar stage in their development. That's why it's hard for them to explore the universe at the same time. But even they agreed that this explanation is way too far-fetched. And finally, one of the big potential explanations is called the Great Filter. This idea was suggested in the 1990s by Robin Hanson. It says that for life to develop and become advanced like us, it has to overcome some really tough challenges. First of all, the planet itself should have a good stable star and good enough conditions on it. Then life has to start on that planet. These life forms need to be able to reproduce using things like DNA. Simple cells must evolve into more complex cells. More complex organisms with multiple cells must develop. And eventually, these organisms must figure out how to reproduce, which increases genetic diversity. And finally, these organisms must be smart enough to use tools, create, and explore things. Finally, they should colonize other planets and star systems without destroying themselves. And maybe one of these stages is so incredibly hard that most civilizations don't make it past that point. This challenge could be something like developing intelligence in the first place, or it might be the struggle to avoid self-destruction. So, perhaps life isn't rare at all, but most of it doesn't go beyond simple tiny organisms like bacteria. Even if the universe is full of bacteria, they don't become advanced enough to build spaceships. The Great Filter might also be something from outside, like a huge asteroid crashing into a planet, a dangerous burst of gamma rays, or a massive star going supernova. These events could destroy life on any planet, no matter how advanced they are. So, if we've already passed this challenge, it means we could be the only ones in the universe and we can explore it. But if we suddenly hear from a super advanced civilization, it could mean the hard part of the challenge is still ahead of us. Now, the Fermi paradox focuses on intelligent civilizations. It just implies that there should be civilizations more advanced than us, or at least as intelligent as us. But if you think about it, why should extraterrestrial life be similar to ours at all? It might be completely different for many important reasons. Life elsewhere might have developed under completely unique conditions. This could lead to forms of intelligence and consciousness very unlike our own. For example, it could have evolved into highly advanced forms that aren't based on biology as we know it. These beings could exist as energy-based entities, silicon-based life forms, or even as a hive mind. And because they have evolved completely differently, they may be capable of things that we aren't capable of. For example, we can't see the entire light spectrum. Our eyes also can't perceive cool things like dark matter. But who knows what the vision of extraterrestrial beings may be capable of? Their abilities might even extend beyond our three-dimensional perception. They might be able to perceive and interact with higher dimensions, which is why they could have unique, interesting insights into the nature of our world. Or maybe they've learned to think outside of time, like in the movie Arrival. For us, we still haven't met them, but for extraterrestrial beings themselves, the concept of time doesn't exist at all. They're simultaneously in the past, present, and future. For humans, something like this is hard to even imagine. Plus, even on Earth, we don't fully grasp how consciousness works or why it exists. We're not even sure when exactly we became conscious. So even if we do encounter extraterrestrial life, it will be hard for us to understand them or communicate with them. We think that they might have entirely different language systems, symbols, and so on, but they might not even have any communication systems at all. As you can see, the possibilities are endless. Evolution is a process that can go in many different directions. It's possible that extraterrestrial life developed in ways we can't easily understand or even imagine. These things are intriguing to think about. There are still no easy answers. The Fermi paradox remains one of the most exciting and mystery questions in science. Scientists continue to explore these mysteries through a multidisciplinary approach. They're hoping to find clues that could lead to breakthroughs in our understanding of alien intelligence. And until we find a definitive answer, we can keep sparking our curiosity and imagination. Psst, a giant is hiding in the sky. Kipu is the biggest thing we've ever found in the nearby universe. It's been messing with our understanding of the universe for years, and we've just discovered it. Kipu is dense, powerful, and dangerous to ignore. If we don't understand structures like this, we might be reading the universe completely wrong. So, what exactly is it? It's not a solid object like a planet or a star, and it's not a single thing. It's a superstructure, basically an entire region of the universe, a tangled mess of matter spanning a huge amount of space stitched together by gravity. Kipu is made up of an enormous web of galaxies, galaxy clusters or giant groups of galaxies, gas and dark matter. It's like a superhighway, with galaxy clusters being the cities, filaments being the roads, and dark matter being the invisible infrastructure holding it all together. This giant stretches across 1.3 billion light-years. That means if you traveled at the speed of light, it would still take you 1,003,000,000 years just to cross it. Kipu also holds 200 quadrillion solar masses, even though it only takes up 13% of the observable universe. The name Kipu comes from the Incan system of knotted cords used to record things, called quipus. It was like a writing system. In that system, each knot, color, and twist told a story, numbers, taxes, harvests, and so on. So, when astronomers saw this colossal structure in space, long, tangled, and branching like space cords, they named it after this language of knots. Plus, the shape of the space reminded scientists of those threads. There's a long central filament, and the smaller ones are branching off the sides. What's even more fascinating, Kipu isn't alone. When scientists mapped this part of the universe, they found 5 of these massive structures. They aren't just sitting there either. They formed over billions of years through gravity slowly pulling matter together. All told, all those giants hold nearly half of all the galaxy clusters in that region, 30% of all the galaxies, and a quarter of all the matter in the observable universe. The team that found Kipu used a clever trick. They searched for X-rays coming from galaxy clusters. These clusters aren't just full of galaxies, they're also filled with superhot gas. That gas is so hot it glows in X-ray light, which we can't see with our eyes, but special telescopes can. If there's a lot of that X-ray glow, it means there's a huge amount of matter, galaxies, gas, and dark matter all pulled together by gravity. That's where the densest, most crowded areas of the universe are. So, by following the X-ray glow, the scientists could draw a map showing where the biggest cosmic structures like Kipu were hiding. Why does any of this matter? Because these megastructures mess with everything. First of all, they warp the cosmic microwave background, the ancient light left over from the Big Bang. It's a faint glow of light that fills the entire universe. After the Big Bang happened and our world was created, it emitted its very first light and signals that still haven't completely weakened yet. The leftover radiation is still coming to us, even after 13.8 billion years. By studying this ancient light, scientists can learn what the early universe looked like, and Kipu ruins it for us. These megastructures hold so much gravity that they bend and distort this ancient light as it passes through them. That's called the integrated Sachs-Wolf effect. These warps add noise to the original signal, and now it's harder for us to get a proper, clearer understanding of what the baby universe looked like and how it expanded. They also mess with the Hubble constant. The universe is constantly expanding, and the Hubble constant tells us how fast it's growing. In other words, how quickly galaxies are moving apart from each other. But giant things in space, like Kipu, have so much gravity that they pull nearby galaxies toward them, messing up the way those galaxies move. This makes it harder for scientists to measure the universe's true speed of expansion. They can't tell if a galaxy is moving because of the universe growing or just because it's being pulled by something huge nearby. And finally, there's gravitational lensing. Light in space travels constantly, but it doesn't always follow a straight line. If the space gets distorted, like by gravity, then the light traveling through the space will get bent and distorted too. Gravitational lensing is when light from faraway galaxies gets bent because it passes by something supermassive, like Kipu here. That huge gravity pulls on the light, like how a heavy ball can bend a sheet. And since light delivers information to us, literally makes us see what things look like, this bending distorts how we see galaxies. The images of galaxies end up looking stretched, brighter, or we can even find an entire galaxy in the wrong place. It's like looking at our universe through a warped magnifying glass. If we're not careful, we could misread those distortions and get the wrong idea about what our world looks like. Luckily, we didn't just drop these mysterious superstructures out of nowhere. Astronomers suspected that something like that should be out there. They just didn't know for sure. Our best model for the universe is called Lambda CDM. It says, universe started with the Big Bang, is still expanding, and is mostly made of mysterious stuff, dark energy, and cold dark matter, the CDM part. We can't see or touch these things, but we know they exist, because if they didn't, our universe would literally break apart. This model matches what we do see, like galaxies forming, how stars move, and the overall shape of the universe. So even if some puzzle pieces by themselves are still a mystery, they match the actual picture. And this model actually predicted things like Kipu. When scientists ran simulations using that model, they saw similar structures forming, giant cosmic webs of galaxies tied together by gravity. Kipu matched those predictions in real life. This also means that Lambda CDM is matching real life once again, thank heavens. No huge surprises here. But now that we actually found it, it's the largest known structure in the observable universe. There was another giant before Kipu, the Sloan Great Wall. That one was discovered in 2003 and was believed to be one of the largest structures ever found. And it's still an absolute monster. The Sloan Great Wall stretches over 1 billion light-years across. It's called a wall, but it's not like a wall you'd find on Earth. It's also a vast cosmic web, made up of thousands of galaxies and gas connected by dark matter. What makes both Kipu and the Sloan Great Wall so surprising is that they literally seem too big to exist. According to the Lambda CDM model, structures that huge shouldn't be common, especially at the time they formed. How did these giants form so fast in a universe that's supposed to be growing, expanding, and smoothing over time? And if we keep finding more of them, that would be completely insane. It could mean there's something deeper going on in the way our world is built. It's all part of our crazy Copernican journey, a long series of discoveries where we just keep getting humbled by the universe. Every time we find something like this, we realize even more how we're not the center of everything. First, we learned the Earth wasn't the center of the solar system. Then we found that the solar system is just one speck in a galaxy. Now, even galaxy superclusters, which we believe to be the biggest, are being dwarfed by structures like Kipu and the Sloan Great Wall. But also, these structures won't last forever. Kipu is temporary. Over billions of years, gravity will tear it apart, breaking it into smaller pieces. Some parts will collapse into tighter clusters, others will drift apart. Right now, though, it's one of the most important structures in the known universe. It shapes how galaxies form. It bends light, making it super important for us to decipher. It literally messes with our understanding of the cosmos.